Good afternoon, everyone. Welcome to the fifth and last day of the International Congress on Music and Mathematics. Hope you have enjoyed all the other 4 days we spent together, and also hope you enjoyed the fifth day. Okay. The program of today is in the same spirit of the other days. We will begin with a roundtable on music signal processing, with discussion made among Rodrigo Schramm, Martín Rocamora, and Bruno Masiero. It will be moderated by Luiz Biscainho. After this, we'll have a conversation about the challenges in research in musical mathematics, especially in the times we are living now. We will have a brief pause. At 6 p.m., we will return with a conference from François Pachet and Jean-Pierre Briot about reflections in music composition assisted by computer. And at 7:30 p.m., we'll have the last concert in electroacoustics. It's very interesting. I strongly recommend all the events happening today. And now I will pass to Luiz Biscainho. Luiz Biscainho was my doctorate advisor and now is a very good friend. And he's professor from the Federal University of Rio de Janeiro, of the Department of Electrical Engineering, and at the COPI. And so Luiz is with you now.
Thank you for your introduction. Welcome to this fifth roundtable of MusMat on music signal processing. It's an honor to coordinate this meeting of three really special guests. I'd like to thank them for accepting our invitation and thank everyone for participating in the event. Let me introduce our guests briefly. Rodrigo Schramm received his PhD in computer science from the Federal University of Rio Grande do Sul, where he is currently a professor in the Department of Music. His research currently aims to develop machine learning techniques for music information retrieval. In the other program, the next would be Martín Rocamora. Martín Rocamora is currently a professor at the Universidad de la República in Uruguay, where he also obtained his bachelor's, master's, and doctorate degrees in electrical engineering. His research focuses on machine learning and signal processing for audio, with applications in machine listening, music information retrieval, and computational musicology. And Bruno Masiero, our third guest, received a PhD from Aachen University in Germany for his work in the area of binaural hearing and spatial audio reproduction. He is currently a professor in the Faculty of Electrical and Computing Engineering at the University of Campinas, UNICAMP. His main research interests are in acoustics and music signal processing. In the first part of our meeting, each of our guests will give a brief lecture around 15 minutes on a topic chosen from their recent research. Next, I will propose one at a time 3 topics for discussion. And in the end, our guests will be available to answer some questions from the audience, and which you can send through YouTube. I think we could start by our most southern guest. And so I'd like to call Professor Rocamora to give the first lecture. Please, Martín.
Okay, thank you very much, Luis, and thank you very much for the invitation. It's a pleasure to be here with you. So I'm going to share my slides. I prepared a brief presentation about our research here in Uruguay, with many collaborations from other places. So I would like to start by saying that our research could be framed in what is known as music information retrieval. It's the processing of digital data related to music, from lyrics to scores and to audio. And most of the systems that are developed in this research field rely on audio. We also concentrate very much on audio. And what we do is we try to go from low-level descriptors that are extracted from the audio signal to high-level musical concepts, such as describing music genres or performing styles or things like that. And to do that, we use signal processing and machine learning a lot. A lot of machine learning is used nowadays, right? So in this research field, we are much interested in expressive music performance. This means that we try to analyze and describe the various ways in which performers shape the parameters in their performance, like tempo, timing, dynamics, intonation, articulation, and so on. And this kind of information is usually not prescribed by the annotated score. And even when there's no score, sometimes there's a difference between what you imagine about what's your conceptual idea of what the music is like. For instance, you may say, well, we have 4 equal notes, but actually when you play it, this may be different, right? And so among this analysis, we try to discriminate. We hopefully be able to discriminate between different kinds of performers and performances, right? And so within this scope, we much are concentrated on rhythm. We use computational tools to try to discover patterns and structure from audio recordings. And particularly, we are interested in micro-timing, which are small-scale temporal deviations from a regular grid you could think of in music, right? So I'm going to give you a very brief idea of the kind of problems and music types we work with. But before of that, I would like to give you an idea of our research approach. We try to bring as much musical knowledge as possible to the methods. This means that there's always musicians or people very much related to the music style or music genre we are working with in the loop. And so we try to seek to formulate with them musically relevant analysis problems. And then we then convert those problems into engineering formulations, right? And this works in a kind of circle in which you start with some questions, you go to the data, you analyze that, then you come back with other questions, and this goes along in this way. So we work a lot with candombe, which is an Afro-Uruguayan kind of music. It's based on playing a certain rhythm with drums, marching in the streets. So the first things we did was to create some data sets. We did recordings and we annotated data sets of audio and video recordings to work with. Then we did automatic beat and downbeat tracking to address this kind of music that it's challenging for some existing approaches. And we then did analysis and discovery of rhythmic patterns with different musical problems in mind. For instance, some of them were related to discriminating different styles, playing styles, performing styles in this candombe tradition. To the left, you have a representation of rhythmic patterns that are grouped, as you see, in different groups. And these groups actually corresponds to different performers. And to the right, you have different representations of the clave pattern. In this music, you have a clave pattern like ka, 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 like in other Afro-Latin musics. But in candombe, you have different variants of this clave pattern. And well, we discovered these variants automatically from audio. Then we also address micro-timing, as I said, small-scale deviations with respect to the metrical grid. And if you have this prototypical representation of the patterns in music notations to the left. We consider some of them that have an ostinato 1-beat motif pattern. If you take, for instance, the Chico drum, that sounds like paraca, 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 always the same. It's usually conceived or notated in division in 4. But if you actually analyze the onsets, as you can see in this figure here, the Chico actually is clearly ahead of the division in 4, and things like that also happen with other rhythmic patterns. We then try to put all this information together, the rhythmic patterns, the tempo curves, the dynamics, and also we compute asynchronous between musicians playing together in order to understand the interactions of the musicians. For instance, how musicians negotiate tempo and dynamics when they are playing together, right? We did also some video analysis to do that. And this was interesting because we tried to approach higher level musical questions compared to the ones we started with. And then we collaborated with researchers at Universidad Federal de Rio de Janeiro, UFRJ, and we did also similar stuff with Afro-Brazilian samba. Data sets were created and things like tracking beats and micro timing were also addressed. And to finish with this, I'll mention that we are also working in collaboration with researchers from Universidad de La Plata in Buenos Aires. And we are addressing the analysis of tango performances from historical recordings. The focus is on expressive timing, and we are, among other things, we are comparing tempo curves, as you can see in the figure above, and we are computing correlations between those curves at different temporal scales in order to see, how similar and different are the performances of different historical figures in this musical style. And I think that's all. How was my timing? You're mute, Luiz.
It was perfect. You took 10 minutes.
Okay, thanks.
Thank you, Martin, for a nice presentation. We will certainly return to it during the questions. Now I'd like to proceed to Rio Grande do Sul and call Mr. Rodrigo Schramm. Please, Rodrigo.
Hello, thank you. I will open my slides as well. I think I have to share my screen first, right? So can you hear me? Can you see my slides as well?
Mm-hmm.
Okay, great. Well, thank you for this invitation. So yeah, well, I'm Rodrigo from Federal University of Rio Grande do Sul. I would like to say at this moment, I'm licensed from the university for a few months for a sabbatical, but I'm still working with students and colleagues from the university. And right now we are developing this research on chord detection or classification of higher chords, which I'm going to present now. So let's see if I can. So automatic chord recognition is not a new topic. Actually, is a very important topic on MIR field. Last year, we have a very nice survey, the 20 years of automatic chord recognition from audio. It was a paper from Queen Mary University and Pompeu Fabra. And I think on this survey, we can also highlight some points that are very important for in the context of automatic chord recognition. Like first of all, we need good feature representation. And I think that's one specific topic. Usually from the early years, we would say that chroma feature is still, even nowadays, a good representation. But then, of course, nowadays, especially in the last years, we will see more complex feature extraction using deep learning. But also another point that's highlighted is we need to find long-term consistency, which is the temporal coherence among a chord sequence, which is also important. And the relationship between music concepts, so the music language, I would say. So of course, chords are also connected with the music genre, styles, composers, etc. So, and beyond that, we have problems when we talk about how to detect chords. We also have problems with ambiguity and subjectivity. So some labels are connected with specific meaning, but also depending of the tonality, depending of the kind of music, they might be ambiguous. And all of this also becomes with a hard problem for machine learning in automatic chord detection, that is the chord vocabulary, which is huge. So basically, depending on your problem, you might have hundreds of labels, and this becomes a very hard and complex problem to address regarding machine learning. And then this traditional method, basically, these are pictures from Maynard Miller from his book, and you can find online in his webpage. But the thing is, these were more like the traditional way when people start, like researchers start to work on machine learning and trying to detect chords. So basically we have audio signal, then we do a kind of feature representation. Usually the chroma feature was very used. And then we do this kind of approach, try to do a kind of pattern matching with templates. And then we have smoothing, transition time, and then chord detection. So for many years, this was the approach that most people trying to pursue, like trying to work on it and try to improve it. But especially in the few last years, 5 years, we will see a lot of data-driven approaches, which is basically deep learning. And of course, if you think about the state of art, you see great improvement. And these two papers here are important because they show us that it's not only like we have now deep learning methods where you input audio signal, and at the end you have a huge network with many hidden layers, and at the end we have a multi-class problem. In fact, they also realized that these models also need to embed musical knowledge. And this is what happened here, where we have, we try to train models and try to include in these models musical concepts like the root note, the pitches present in the chord, the bass, fundamental frequency, and all other kind of features. And also they try to create this kind of hierarchical models where you can detect it like a triad chord, but also you can add notes, and then maybe if you detect the triad, you might also find additional notes and have more complex compositions with inversions, other kind of root notes. But the thing is, I'm just showing this because basically data-driven means that we need data, and this is one of the difficult part for this kind of algorithms. So you think about chord classification, we can find a few data sets available, and you're going to see that most of the chords and the examples in these data sets are for major triads and minor and go so on. So the figure here on the left can show us that for very hard chords, like unusual chords, we don't have much examples for them. And then, and on the left, we have this data set that was using in Young paper. So we have 1,200 example songs and combines isophonics, billboard, and more. So these three data sets. On the right, we only have the isophonics isolated just to show is even worse. We have almost more than half is just major triads. So in some of the chords or the samples are not even represented in the data set. So how can we expect that a machine learning system, a deep learning model, will learn something that is even not present in the data set? Well, so for sure we need more annotated data. This is something now when you think about machine learning, AI or whatever, we need annotated data. But so among the common strategies, I would say annotation by experts are one of the most important, but they are not feasible. It's difficult. We are not talking about like hundreds of annotations. We are talking about 100, maybe millions. So we are talking about a lot of data. And that's not something usual and easy to do. So of course we do, researchers apply synthetic, they try to generate data with synthetic data, like MIDI files, etc. They do also data augmentation. So they start with a small data set and try to do pitch shifting and add noise and try to extend this data set. But especially in the few last years, a different approach start to think about weakly labeled examples, which means that we can, instead of trying to train a really good classifier using very reliable data, maybe we could try to find ways to work with not reliable data, based data without labels or weak labels, okay? And of course, when we talk about this, we have a model that we will learn from a lot of data with a lot of noise. So this is what we are doing now. So it's our research at the university and my group. So we want to deal with noise labels and unbalanced classes. So for that, we apply two different methods. I mean, we are combining different methods, but basically what happened when we have unbalanced data. So most of the data are like major triads, and then and worse than that is not more often, these very often examples, they are easy to detect. So what happened when you try to train a deep learning model with these data sets, they learn the easy examples and they ignore the other ones. And that is the big issue here. So we have this idea, not the idea, but this approach that is the focal loss, where we try to lower the power of each example. So basically we want to give more importance for the hard ones. And then we also try to combine the idea of self-learning, which is based on the noise student technique, which I'm going just to explain quickly here. Basically, we have a reliable data set, so a small data set with very unbalanced examples. And then we have a deep learning model, which is a deep learning for chord detection. We call this the training teacher model, where we detect, chords, and we classify chords from one. Well, we train the model first with this reliable data set, and we use this teacher model to detect an external data set, which is very noisy or unlabeled or weak labeled data set. So for this data set, we use external procedure where we gather information from the internet. So basically we have many thousands of examples. Most of them are labeled, well, we have no idea if they are correct or not, but we have the audio examples, and we apply the training teacher to extract the labels for this huge data set. So the filter examples are then ranked based on the confidence measure. We do augmentation on it, and then we use these new examples, the best in the ranking, to increment the reliable initial data set. So, and the important here is that the focus is to not only to add new examples, but also to make it more balanced. So this is a very, is a cycle, so we iterate on this. So every time we have a new and extend the data set, we train the model, we believe, hopefully the model will be better. And then with this better model, we can select better examples and we go on. Well, just one example, when we do that, so we have this initial data set on the left for the isophonics, and on the right, we have the isophonics plus the filtered examples from the noise. And then you can see, even it's still not ideal, but it's much better balanced now. And of course, what we wish is that the final classifier will also be more efficient, have better accuracy. So this is what we do. We have preliminary results right now. Usually we use the weighted card symbol recall, which is, it's a bit unfair because basically it looks for the overall accuracy. So if you have like the major triads, that will be the majority. So when you try to use this metric, it basically you ignore the hard and not often examples. So this is why we also apply this different kind of metric that's very important for chord detection nowadays, is the average chord quality accuracy, where it takes in account the individual classes, different kind of chords, and then we average among them. So this is what we have here. So we have the baseline, which is a data set, the initial data set, where we train and we classify the chords, and then we have the improved data set. In this case, you can see that the overall accuracy doesn't change much, but when you look for individual accuracy, the average individual accuracy for each class, now we have a kind of considerable improvement. So this is what we are looking for. We already had some good results here, but still we need to expand and try it more. Well, conclusions. What I can say, data-driven is the way to go, right? So, I mean, there is no way back, I would say. We do need, and we still are using music language and knowledge, musical knowledge for design these models. Still, we need more annotated data for sure, but we believe that robust learning techniques can improve classification. And then we can also use this methodology to extend and create new data sets that can help, hopefully, for designing of new models. So yeah, that's it. Thank you.
Thank you very much for your presentation, Rodrigo. I'd like to ask the audience to take note of the questions they'd like to ask about the talks for the end of the meeting, okay? Now we go a bit to north, to São Paulo State, and call Professor Bruno Masiero to his talk.
Just make sure that you're all looking at my slides.
Yes.
Yeah, great. So first of all, thanks for the invitation, and let me start by saying that I am probably the black sheep in this talk, as I'm not an expert in machine learning. As Luiz said in my introduction, I come from the field of spatial audio and binaural reproduction, and that's the topic of my talk now. But I will give some flair of where we can use machine learning on this subject. So I will start by doing a review on the field of spatial audio. And well, just to talk about audio, we need to start with communications or music. And at the very beginning, everything was live. You need to have the source, be it music or speech, happening at the same time and at the same place as where the listener was. But then at some point in the 1800s, microphone was invented, loudspeaker was invented, and then we could record it, sound in one position, reproduce it in another one. And that's where we started live transmission. It started maybe one of the first situations we know was that you could listen to the opera from the hotel. Of course, it didn't take much time till people realized you couldn't, maybe you wouldn't be able to listen to it live. So they designed recording systems like the phonograph designed by Thomas Edison. And that's where the phonographic industry was born. At first, it was monophonic. That means you only had one microphone, one loudspeaker. And that was good enough. People were very happy. But with the development of our society, soon enough, people wanted more. And the next step was stereophonic sound. Important to notice is that the term stereophonic comes from Greek stereo, that means spatial. So with 2 channels, people were already very satisfied. They were already thinking that that was coming from mono to stereo was super involving, and the spatial impression was already much better. Of course, you could record with stereo later on, and the development never stopped. Cinema was the main drive for the surround sound coming from the surround home theater, surround cinemas that led to the home theaters. We're using 5 channels, and the development went on to switch from LPs, from vinyl to CDs, and then compression with MP3. And that's more or less where we are now. But are we satisfied? The answer is no. We're still looking for new developments. And the next place to go is to use array of loudspeakers that could provide you with the impression of sound coming from everywhere. That means that you are immersed in the sound field. I will talk about that later in this talk. That might not be financially, economically feasible. So there must be other options to an array of many loudspeakers. But then the other question is, if I was to use an array of loudspeakers, how am I going to record sound for that spherical or for that spatial reproduction? And where we are seeing now is using array of microphones. So that's the other point I'm going to briefly talk with you today. And in the end, there is also the aspect of coding it all, because now you have many microphones. That means many channels. You have a lot of information, and you want to get that through a network of data that you want to use as few data as possible. So you need some very good codecs to work especially on spatial audio. So what we're gonna talk today, and you're gonna see I tried to translate my slides, but some of them still have. We are gonna talk about recording, coding and decoding, and then reproduction, starting with recording. So there are 2 main paradigms on recording side. One is close miking. That means you just place one microphone close to each source, very demanding. The other one would be to use an array of microphones. That's what we usually do when we do recordings nowadays, when you use an AB microphone or an XY microphone. That means 2 microphones that we already record in a stereo way. And when we talk about arrays of microphones and coding that in a spatial audio format, then we will need to do sound source separation. And this is already one point that I noted out here that is a point of research for machine learning. Going further on the reproduction side, there are three main paradigms here. We may talk about penning, we may talk about sound field reproduction, or we may talk about binaural reproduction. So I'm gonna go very briefly over the three of them, starting with penning, which is our traditional stereo recording. And the idea here is that by changing the relationship between the two sounds that are being reproduced by the loudspeakers, be it the delay between them or the amplitude between these two signals, you can provide with spatial impressions that can be expanded, and that's exactly what's been done with the surround sound, or the 5.1. It is based on the same principles as stereophonic. And you could think of going further and expanding it to a 3D penning technique. And that has been done. One of the main examples is the vector-based amplitude penning proposed by PUC, which chooses, decides which direction you want to reproduce your sound. Look which are the three loudspeakers that are closer to this source, and calculates the weights to these three loudspeakers. So that means we are always using the least amount of loudspeakers possible to reproduce the sound, and that does give some coloration to the reproduction. The opposite situation is proposed by Ambisonics, where they say, let's use all loudspeakers available to reproduce sound. And it's based on the spherical harmonic decomposition of the sound field. Not going to go into details of that, but if you're curious, there is a video on YouTube in my channel on YouTube where we discuss further on that. Unfortunately, it is in Portuguese. But when using spherical harmonic decomposition, you do want to have a spherical base or a spherical recording, sorry. And that is why we see a growing number of spherical microphone arrays being used for spatial recording. And to reproduce that sound, you might want to have a spherical or half spherical loudspeaker array. This is the microphone array we have at the lab, and this is the loudspeaker array we've set up in our lab as well. But one big question is, I'm talking about ambisonics, but is it a penning system? Or is it already a sound field, a wave field system? Meaning, does it synthesize a new wave field? And it is actually a hybrid. It depends on the number of orders you're using to decompose your sound. At lower orders, it works based on psychoacoustic principles. That means it's more of a it's more of a stereo sound. Otherwise, if you're growing your order, it becomes a wave field synthesis method. And talking about wave field synthesis, what is that? That's if you want to record how the wave is propagating in a space and then recreate the same wave field in another space. Problem with this kind of methods is that they require lots of microphones and lots of loudspeakers. And they've been, there was huge research on that in the beginning of the 2000s, but they've been left aside nowadays. And to conclude, the last reproduction technique is binaural, where you take into consideration the fact that we receive all spatial information from the sound that arrives at our two ears. So if you are able to record the sound at your, or the interest of your 2 ears, or synthesize the sound as if it was arriving at your 2 ears, and then reproduce it through headphones or in somehow guaranteeing that there will be no crosstalk between these signals, then you will recreate that spatial impression. Good. Knowing all the recording techniques and all the reproduction techniques, we come to the coding and decoding aspect of spatial audio. And the new method that we are looking at that's been newly proposed is the spatial audio object coding. And the idea here is that you don't work with channels anymore. So you're not talking about stereo that has 2 channels, or you're not talking about 5.1 or 22.2 or whatever. It doesn't matter how many microphones you used, how many loudspeakers you have to reproduce. All that matters is the objects, are the audio objects that you have that are fed to your encoder, and it does its magic, derives some channel that goes through your with very low bandwidth through your network, and at the decoder side it will recreate that object, and the decoder side has a renderer, and that's why I talked about all the reproduction methods, because this renderer will be able to receive the information from the user which method he wants to listen to that music or to that sound. And the renderer will then use these objects and place that in a scene and then reproduce it via headphones, being it binaural or stereo, or through loudspeakers, being it ambisonics, VBAP, or stereo. But then the one question is, how do I get to these audio objects? And that's why I highlighted the recording with spherical microphone arrays and blind source separation, because for live situations where you're not able to do closed miking and have the individual recordings from each sound source, you will need to separate the sources, being it by traditional methods like beamforming, or using blind source separation, which now goes ever more in the direction of machine learning, or some other methods like compressive sensing and compressive beamforming. And with that, I conclude my talk, and I'm eager to start the discussions.
Thank you, Bruno, for your presentation. We had three very interesting talks. The first one on rhythmic analysis of Latin American music. The second on automatic chord recognition for not usual chords. And the third, we discussed the problem of recording, coding, and reproducing 3D sound. I think we have a lot of things to exchange in the next parts of the meeting. Now, I'd like to suggest that we discussed in a more freer way some topics I tried to prepare as teasers. I think it should be interesting if I could show the questions to everyone. So I will share the screen. Is that clear? Well, the first thing I suggest to discuss is around this topic. Machine learning has been widely used in music, especially by composers, for example, in algorithmic composition, for decades. Recent developments have improved the state of the art in everyday applications such as voice recognition. It's a great revolution in telecommunications. But I'd like to know in your evaluation, which applications in music now could be most impacted by deep learning and methods like that? You can start as you wish.
I don't know how, can I just start?
Please.
Give you my opinion,
Yes.
maybe?
It's okay.
Is that okay? Okay. I mean, well, that's an interesting question. I would say that we can apply in machine learning and deep learning any kind of musical application, I would say. But of course, for me, I mean, there are some applications, even though I was talking about chord detection. I mean, people can do that by, I mean, music experts, they can listen and they can annotate it. I think something that will be very useful and is already is actually if you can apply deep learning, machine learning for big data. Because, you know, if you think about, okay, like if I want to predict the kind of musical hit in the next year in Porto Alegre, I mean, this kind of stuff that nobody will be able to predict, I guess, but maybe a machine that can, you know, consume data from everywhere in the world and then might be able to do. I guess these applications that goes really beyond the human capabilities might be one of good contribution to the humanity, I would say. Well, just a first topic, actually. I don't know if you agree, maybe you just think that's bullshit, but please go for it.
Yeah. May I say something?
Yes, please.
Okay, so I think something that's gonna change the music applications landscape, as I see it, is that's been alluded in our talks, especially in the last one, is source separation. I think source separation is an application that is a core application, I'll say, in MIR, that's improved a lot in recent years because of the application of machine learning techniques. And the results we are getting with these techniques are really good. Of course, there's some room for improvement, as always. But the fact that you can actually separate sources from mixes, natural mixes or mixes that were created in the studio, I think it's a kind of game changer, because now you can imagine many other applications related to music that could benefit from that. And so there are applications like creative applications like DJ remixing, in a similar way, like in the past in hip hop, you used samples from recordings. Now you can do this, but not only the sample, but the specific sound in the mix that you want to use. And this is kind of very, very interesting. And so I think that source separation is gonna change many applications in the music production and the music creation. And well, and I agree with Rodrigo that machine learning can be applied to many other problems and fields related to music. And I guess we are gonna see some important changes in other applications. Of course, there's gonna be some particular applications or particular uses of computational tools that are not suitable for machine learning, at least for deep learning. But I guess lot of, as to sum up, I would say that a lot of, or almost all the different applications related to music somehow would be changed because of the use of machine learning. It's a strong position, so let's discuss about it.
Yeah. I just would like to add something, I always has this thinking about, if you can do source separation, if you can use AI to generate new music, then we also have a discussion about copyrights. Because also, and this is a big challenge, and I mean, I don't know, I don't have an answer for that, but that's for sure something that people have to think about and have to discuss about. Because even if you do source separation, then you can reuse, but then you have copyrights problem. But if you have, I'm just wondering what happens if a machine generates a song that's really similar with previous copyrighted song. Who is the fault then? Because I developed the algorithm, but actually the machine learned by itself and it generates something. I don't know if you are prepared, if the society is prepared for that actually, but it's something that for sure will be discussed soon.
So as I'm not the music as deep as everybody else in the music research, I might take my answer a bit far out, but yeah, as been said, I do believe that machine learning will have an impact in music production, in the creative process of it. But I see, at least for the next few years, I don't see it coming to the music production in the next few years. However, it is already impacting our daily lives in many aspects of our sound communication. Probably our voices are all being filtered by a machine learning algorithm right now through a Zoom algorithm. Google has also introduced their machine learning noise reduction algorithm. And it's all based on voice detection algorithms that worked, that had achieved a level of quality that wasn't improving anymore. And with machine learning, they were able to step a bit further on. And that is, as Martín was saying, it is related with sound source separation. So they now are able to detect, am I talking or not? And that will feed to an algorithm that will be that separates the sources and now knows what is noise and what is voice, and we will only let my voice out. And the developments, somehow they will flow to the music production. I can't really speculate on how yet, but once the technology is there, the creative minds will be able to use it.
I'd like to make a point. In fact, the pianist Glenn Gould, many years ago, said the future of recorded music would allow the user could make his own mixes. And this is one interesting thing I think we are going towards. Because if we work on object representation, multi-channel, and the ability to record and separate the different sources, I think this will be a trend. I'm not saying that all users would have the technical prepare to deal with this kind of thing, but I think we will allow something like put the focus on the voice and eliminate the drums and so on. This is probably
Luiz, and they will have to learn once the technique is there. The artists will have to learn how to use it wisely. So probably in the beginning we will see people splitting note by note and placing every note in one direction, and you're just feeling a musical cacophony. And then later on, they will slow down and say, okay, I just need a bit of spatialness here and to get a bit less drums and so on. In the beginning, there will be probably some over-tuning, but then things are going to slowly fade out.
Just wanted to add that this kind of technology is actually present in the studios right now, in music production studios right now, because some techniques were sold to the major companies that create software for studios, and gradually they are integrating plugins or processing capabilities of doing source separations with the results or with the approaches that we were talking about that use deep learning. Isotope, for instance, which is a software that's used for processing audio signals, has incorporated very recently a plugin for that. And there's also the example of DJ remixing that I mentioned is actually a product that's being sold.
Luiz,
Yes.
can I bring a comment from YouTube now? I prefer not to let this comment to the end because it is very correlated with the topic on the copyright. Rafael Merlo mentioned that he believes, from his point of view, that the copyright belongs to who programmed and or created the machine. And he quoted that the musical sociologist Dani Ribas has good points of discussion about these topics in her research. I don't know what I think about the copyright belonging to who programmed or created the machine.
Well, I don't know him neither. I mean, I think there's a very complicated topic, but I think I'm more worried about not to belong or not to, but to make somebody responsible for breaking the copyright act. That's another way to think about it as well, you know. Yeah, I mean, I know, I think that we will have a lot of discussion, and thanks for sharing this person that might, I mean, I think you should go and read about, because I'm sure there's some people work on this subject. But also, I think we are seeing a revolution right now, because there is a company, I think a startup with I think is DEC, no, it's Jukebox, and they have the system to generate music, automatic music, and I was just imagining, like, because you can upload some examples and it's recreate based on these examples. So basically, if, you know, I'm just thinking about when I was young, I had my band, rock and roll band, rev metal band. I love that song, and they are not producing anymore. I was just wondering, maybe I can ask the system to create a new song from that band. So I just upload all the songs and I have a new one. And then I was even going further, maybe the band, I mean, I could even buy new songs from the band before the band released them. So it's kind of crazy thinking. And yeah, but I think we'll have a lot of discussion, and this is gonna happen soon because it's already happening, basically. But I'm not expert on this field, so I would prefer not to give like a really solid opinion of that on that.
Luiz, I have a question for the members of the roundtable that is correlated with the first topic. Do you prefer that I made it now or after the three topics are discussed?
Yeah, we have time.
Okay. So the original question was about machine learning in music. So thanks to Biscainho, now I am teaching statistics, and I see a different perspective in statistics and in machine learning. Loosely speaking, in my interpretation, machine learning is more addressed towards better metrics and results, and statistics is more tends to prefer a better modeling of the objects or the data or whatsoever. So when Rodrigo was speaking, his talk was about improving the classification of rare chords, okay? And in statistics, there are a lot of literature. I'm not so aware of this. I only know about the existence, but I'm not a deep know of this theory. But there are theories that treat rare events or extreme value theory that, in my opinion, tends to go in a distinct direction rather than improving the database, but improving the model. So I can see two distinct trends to deal with difficult problems in this direction, improving the models or improving the quality of the database. I will be very happy if you can give some words about this.
Right. Well, what I can say, like from the past few months, we were trying to improve the model, trying to specify or design a model that is able to, I mean, and somehow we are doing that. So when we say that we have these focal laws, we try to design a model that in somehow learn better characteristics from the examples. But the thing is, if you say, okay, I have this label and a feature and a label, and we connect this, and then I have the same feature and then say, this is another label. It's a bit unfair for the network anyways, because we are just giving two examples that we have the same input, but the output is different. So in this sense, I think we are introducing this noise to the system. Of course, then we can think about how to model in a statistical way, but in fact, you can design a network to be a statistical model anyway. So it's just a different thing about it. But I mean, this is really indeed different way to think to address the problem. But I think that's important anyways. In some way, we have to address to increase, to make the network robust, but also need to figure out ways to consider that we will have. I mean, I think it's just a way to think about it, but at the end, result will be similar. We have a model that's efficient, but also that is able to maybe to filter the input. Yeah, I mean, maybe it's still a bit confusing, but yeah, hopefully we will have better results at the end. We will be able even to look back and to, because that's another problem. Right now, most of the networks that we use are based on state of the art. So we are not actually design a network from scratch, you know. And this is also something interesting because, well, those networks are really well designed because the concept behind the design is very well defined. But still, sometimes we can just do the opposite way. So we learn, we try to improve the model, and then we go back to see what the network have learned. And then try to understand from there. And then from this learning, we may change and redesign again. But I mean, I think by now, I would say that we are exploring more than trying to define something because we are really in the early stage.
May I add something? I think that, yes, can I? I think that the question is really nice. I mean, it make me think about when some years ago, all this boom in machine learning started, and we in our group, people from coming from signal processing with the hardcore signal processing background, start to think about this and say, well, actually, by using this machine learning approach, you don't have models, something that Hugo said, and you don't know what the system is doing, and all those questions came up. And I think that they are, of course, they are valid questions, but I'd like to raise two points about that. The first one is the use of machine learning purely as black box is changing. There's a lot of work on explainability and interpretability of machine learning that it's super interesting, and it's a key issue right now in the development of the field, I guess, because when you try to put these systems in production in areas in which you need explainability, this makes I mean, it's really necessary. And the other, so I mean, I think there's very nice work on that you could look for. There are very nice questions posed in this field, and I think that there's also a lot of debate around this. Do we need to lose performance in order to make the systems more interpretable and things like that? And very nice discussions are going on in this field. That's the first point. The second point is, at least in our group, we remember I say that we had those questions about, well, you don't have models, how can we deal with that? And I think that the conclusion we ended up with is that it's a kind of practical conclusion, but I think it's good. You are getting very good results with this approach. So despite the fact that the tools you were used to were different, maybe it's time to embrace this new field with your own background and try to interpret and try to put your perspective in this into this new field. And well, I mean, new for some people, right? And I think that's the way in which our group is taking this challenge. I mean, there's and if you try to enter into the field, there's a lot of things you can do from your perspective, and there's a lot of contributions you may have from either a pure mathematics or a pure signal processing background.
I mean, we are out of time, but can I just put a few words there? May I continue? Yep. Just thank you, Martin. I think you helped me a lot with the answer, and also, I mean, there is another point is that nowadays we have these huge models that are able to, we can get really good results from it, and a kind of early research is how we can then compress these models, because I mean they might be useful in the cloud, so huge, but you cannot run in your mobile phone or in bad applications. So again, even with this black box is working well, of course, in some case we have to understand and try to compress to make it to work or have a similar model in order to run in real applications. So still, I think we have still have a lot of research in this topic for years.
Gentlemen, thank you for your comments. It was very enriching to hear them, but I'd like to proceed to the next topic. The ability to allow detailed analysis of musical performances is one of the most enriching contributions of signal processing and machine learning to musicology. At the same time, today, all kinds of artistic manifestations are easily disseminated to a universal audience. Can this not lead to a general standardization that undermines the authenticity of regional cultures? What do you think about?
I might start. I still think, and this is just a personal question, personal opinion, not technically founded, but I think that the human culture is strong enough that even with all this technology, there will be still the regional differences and local cultures. They might be influenced, they might change because of all the contributions, but I still think that in each region we will still see different flavors of it all. But as I said, that's just my feeling.
You see that as a natural development.
Yeah, I believe that it will influence somehow, but I don't see it standardizing. It won't be like an L infinite that everybody's going to be the same.
Okay, may I say something? I think it's a nice question, but I have two comments about that. The first one is from my experience dealing with a particular community of musicians here in Uruguay, the ones that I mentioned in my talk that played candombe, and you know, currently there's a kind of I mean, candombe, it's very popular here in Uruguay nowadays, and so it happens that the actual families that are in charge, I would say, of this tradition sometimes get aside of the main the TV shows and the main media related to candombe, right? And so that's something that happens with or without technology. This is something that's happening here in Uruguay, at least. Talking about this example of a cultural heritage that's somehow is spread over the whole country. But at the same time, I would say that our work with musicologists and data scientists and engineers that are addressing the analysis of this kind of music, I would say that it actually has helped. Maybe I'm overly optimistic, but I would say that it actually has helped to put some of those parts of those communities in a position, in a better position to raise their voices related to what they think the traditions are, what they think their musical forms originally are, and somehow they were able to stand in I would say in better position in order to differentiate from what's happening outside the community. I mean, if the academy, if the people from the academy goes to them and do recordings and do analysis and publish papers and do some research on their work, and they say, no, these people here are the ones that own this culture and own, at least they're the ones that have this tradition and develop this tradition for, let's say, 200 years, right? And this is something that could be positive. And so it depends. I would say that it depends on the way that the signal processing and machine learning and things like that is used. If it is used with respect for those communities, I think that the results could be, instead of negative, as the question poses, could be even positive.
Well, I totally agree and support Martín in this. Martín, I think, is really opposite to the negative part of the question. I think it's a really great question. I have no musicological background to discuss maybe this, but my feeling is that actually this kind of technology will help to preserve these regional cultures at some point. If you think about I know the advanced technological advance of sound recording, when they start to record, that's also help until nowadays to preserve regional manifestation, cultural manifestation. I think I'm not saying that's dangerous. I think that has more impact if you think about like social media, Facebook, YouTube. This can have much more impact on regional culture than maybe this kind of technological tool. Well, that's what I kind of believe. But yeah, I totally agree. I think Martín is totally right. I think the tools might be very helpful.
Any more comments?
I think today I'm overly optimistic about everything. I don't know what's happening to me, but I'm not. It's not always the same. Every day I'm not in this mood.
No, I know that.
It's Corona, it's COVID-19 that's happening.
Yeah. And add that in terms of preservation, we have more conditions to bring old recordings and folkloric registers to the common public after a good procedures of restoration and creating archives that can be assessed by the public. I think this is very important to guarantee these cultures are preserved. So, Jan, should we proceed to the third topic? We're running out of time. I say the use of advanced mathematical and computational tools in music creation is a strong stimulus to new and revolutionary ideas. Contemporary music seems to evolve towards increasing complex and unusual directions. This is not my preoccupation. I just try to compile some ideas I have heard of some colleagues. Is this compatible with the need to bring together ordinary people and culture in a country like Brazil? Or we are going too far into the abstract? This is the question.
I would say there is room for every kind of music, even or especially in a country as big as ours. So there will be niches of groups doing very contemporary and computationally based music, as there is, mainly in universities here in Brazil, in our case. And ordinary people will still be doing their thing. So I don't see why one kind of music would not influence, but deny the continuation of the other kind of music. On the contrary, I think there is room for everybody.
Mm-hmm.
Yeah.
Well, go ahead.
Please, Rodrigo. No, yes.
Okay, no, I was just saying that corroborating with before, like nowadays with MIR tools or any not only MIR, but these new machine learning tools, people are able to make new songs and new music. You know, so I'm not sure what you mean with ordinary people, but I mean, like people from home, they can just get a mobile phone and create new stuff. So if you can provide new tools for contemporary music, or I mean, that open the mind to create new contemporary music, then I think the tools are really helping in this sense. But of course, again, I'm not sure about ordinary people, but I think about more like composers and scientists, how they think about that, how they study this topic. Then of course, we need also to provide research and studies in the academia to generate a new composer, new scientists as well. So yeah, I mean, I think there are a lot of potential to create new stuff, but also we cannot forget about the academia, because that's really important.
In fact, I think this is an excellent opportunity to bring new ideas and new music to ordinary people, as the question said. Martín.
Well, this is somehow related to something that I said in the first question. I think that musically inclined people all over the world, but especially in Brazil, they're gonna embrace this kind of technology, and they're gonna use this kind of technology in different creative ways, even ways that we don't imagine now. And so, as it happened with hip hop and you know, the samples that they were used in another way, I think that this kind of technology for sure is going to be used for creating new kinds of music. And in a country like Brazil, that is so musically inclined and that has so many great music traditions, all living together peacefully, I would say that it's a place in the world that this is gonna flourish, particularly in a particularly interesting way. But of course, there may be some risks or some endpoints for some initiatives, of course. And well, I'll say that young people, musically inclined people, of course, they're gonna embrace this kind of technology and create new ways of addressing music creation.
Mm-hmm. Okay. Hugo, should we proceed to the questions from the audience?
Let me add another thing. I usually follow some musicians, some Brazilian musicians in YouTube. And I recently heard one of them saying in an interview that these are great times for musicians, he said, because there are many ways of disseminating their music, many ways of communicating directly to their publics, and easiest ways to record and create their music. There are no, of course, this may be not easy for some musicians that are used to other ways of doing music or other ways of living living in the music world, right? They are not going to be in their homes, waiting for someone to call them and say, please come to my concert and come to play with me. Maybe these ideas changed, but as this guy said, I think these are good times for music. Music's still very, very much alive, in Brazil in particular.
Thank you very much to our guests for giving a positive bias to the second and third questions. This was the best way to address them. And Hugo, do we have some questions? Hugo?
Hi, Luiz. I have a brief question that I want to essentially go again to the first point that you made and join with a question that I thought when Rodrigo was talking. He said that the chroma features are still very a good balance between computational cost and results to obtain good results in chord detection, okay? And we extensively discussed about machine learning, and obviously machine learning automatically leads our minds to thinking deep networks. So I want to know your opinion about the autoencoders can be interpreted as a way of automatic feature builder. If I have to explain to a pedestrian what is an autoencoder, I would say this. So do you think that autoencoders can help discover new and not intuitive features or give interpretability to some weird features that can be useful in music information retrieval?
Well, that's an interesting question. Actually, autoencoders are used a lot for that. Autoencoders, convolutional networks, I mean, the idea is to represent, or autoencoders also trying to reduce the dimensionality of the feature space as well. So, I mean, of course, sometimes this latent space or this, you know, the space defined by the autoencoder might not be so easy to interpret. I mean, of course, it depends on the number of dimensions, how you connect this layer with the input. But I mean, if you design autoencoder, maybe it could be just a chroma feature representation at the end. You know, you have like, it could be. And I would say if you design well, depending of the training, how you train it, it can learn the chroma feature representation. I mean, that's very interesting question because years ago, like before deep learning, we were using traditional methods to extract features. And then you use a kind of classifier like random forest or even networks to do the post-processing as a classification after you extract the features. But then with deep learning, and this is the good thing from deep learning, because deep learning not only learns how to classify, but also how to learn the best feature representation. And I think that's the big deal with deep learning nowadays. So it makes a lot of sense. I'm not saying that's easy to interpret the feature space, but for sure, if you have enough data and a good model, it's going to learn the best feature representation for the task, the classification task. Well, it depends, of course, the task, right? But if it's a classification task, for sure, it's going to be better than if you hand code features. But of course, this is a huge area. There are some people that embed like they combine some hand coded, like you could combine chroma features and then learn different features from the network as well. So, I mean, there is no only single answer for that. But yeah, what I can say is that deep learning nowadays, if you design well, we can have a really good feature representation.
Okay, thanks.
I'm sorry, I'm not sure if I answered the question, but welcome.
Sure, as you said, there is no answer for this question, but I wanted just to hear your point about this.
I have a question to Martín. Do you feel prepared to use deep learning in terms of databases for the applications you approach with Candombe and Samba and so on? Do we have sufficient databases to use to approach the problems using deep learning?
Well, it depends on the kind of problems you're talking about, because if you're talking about the high level questions I mentioned, like performance analysis and to analyze the interaction between musicians and things like that, maybe we don't have enough data because I mean, we have dozens of recordings, which probably is not enough for doing this completely automatically and completely learn from the data. But on the other side, there are many other tasks that are general, and we may benefit from the solutions that are proposed using deep learning. For instance, chord detection, or for instance, onset detection, or beat or downbeat tracking. And I think that or source separation. So using these new methods in the realm of computed assisted musicology, I think it's a reality now. I mean, it's something that we of course can do, and we are actually doing, right? Because we are using deep learning. Some of the papers I mentioned in my presentation actually use deep learning in some stages of the processing, or in order to solve some part of the process.
Thank you. Bruno, when we talk about object-based representation of objects, I always am a bit confused about the dispute between natural recording of the complete scene, then separation. You have, for example, the microphone array, separation, which is not perfect, and then remixing as you wish. Against, if it is possible, the separate recordings being post-mixed, artificially post-mixed. What is the need for the first strategy? When we really need to record everything and separating them, the mixing, instead of recording separately.
So let me get if I get the question right, is when do I do only close miking and when I do only the array recording?
Yes, because for example, in films, you typically record each track separately and then do post-mix. You don't use natural scenes because it would be a great mess to bring in noise and unexpected effects of the positioning of microphones. And this is my question: why using the natural recording with the array of microphones and then separate them and then mix instead of separating?
Okay. So where do we see that it's being used ever more often is, for instance, in live recordings, where you're not able to place, and I'm not talking about recording of music. Of course, if you're going to record an orchestra or a band, you're going to go for closed miking, or not from each instrument, but at least from a group of instruments. But if you want to record the ambience of a stadium, you might want to go for the array. Then you probably won't use that in a movie. If you're doing recording for cinema, then you really want high definition and you're going to go for closed miking. But for general recordings, outdoor recordings, where you do want to get a feeling of the audience, that's one possibility. And the other place where I see it being used quite often is for soundscapes, study and recording of soundscapes. And it's still not in any norm or defined anyhow, but it might come to the point where if you want to study noise, ambient noise, you might want to have some sort of spatial descriptor in it as well. And that would lead you to array recordings. So there are several possibilities, but as I guess your point was made on music, and yes, especially for musical recordings, you might still want to keep the closed miking.
Okay.
And there's one point that that I've just realized I forgot to mention in my talk was there is a big discussion. I don't know of any system working like that, but in the coding part, to use an autoencoder, and that's when Hugo said autoencoder, I remember that. There are people thinking about using machine learning to do the encoding and decoding of the signal, to instead of using traditional methods, just let an autoencoder run and then use just the encoder part and do that as your spatial audio object coding engine.
Okay. Thank you, Bruno. Well, Bruno, Hugo is almost killing me because we passed 5 minutes of deadline.
It's worse.
So thank you very much for your talks and your discussion. It was a great meeting. Thank you for the audience for participating in the meeting. Hugo?
Thank you.
Thank you. It was a pleasure.
Thank you very much for the invitation. It was good to see you guys.
We thank you for the participation and also Luiz Biscainho for the moderation of the roundtable. For me, it was very enlightening to have this discussion with you guys. And now we'll pass to the next activity of the conference that will have a big roundtable about some challenges of research on music and mathematics, especially in the times we are living now in the social distancing. So who will have the word? I think it's Liduino.
Say that again, Hugo, please.
You have the word now. Start the works of the table.
Give me a second, Hugo.
Okay.
Maybe you could start with a question, Hugo, for the people.
Okay. Only to close this last activity, we have some comments on YouTube congratulating for the tables and for the discussion. I think it was very fruitful for other people. So I want also to tell if someone that is still here in the Zoom chat and wants to stay for this table, have no problem. Okay, feel free. And we need to start this table. We want, or better, I want to start this discussion with a more reflection than especially a question addressed for specifically one person. For me, it's been particularly hard to manage the work from home because it's very difficult to do everything from the same space, to sleep and to work and to have my free time, everything in my 9 square meter room. So I think that I am sleeping worse and I am working less. And in another direction, I'm working more hours per day, but my effective working is not so good as when I was going to the university and spending 2 hours a day in the traffic to go and to return from the university. And I want you to share what are you experiencing in this direction, especially I think that people that are in other countries, Martín, Rodrigo, and François, I think that it can be good to hear what can you say about how are you managing this. I don't know if there's any other one in another country, but go ahead, guys.
You mean how to manage like the professional life, personal life, and everything, right? You said. Oops. Oh, no. You hear me?
Sorry. Yes, we hear you.
So, sorry, just to get your question was how do you manage your the mix of your personal and professional and everything lives at the same place, right?
Yes, it's not a question. It's how are you? Is a yes, can be. How are you managing all this stuff together in these hard times?
So I can tell you because probably my position is probably not very. Is not like most of yours, I guess. I work in a private company called Spotify, which is pretty much international. I mean, it's a lot of different countries, and so I think that like many tech companies, they are very cautious about their employees, and so they decided in March. What year is it today? No, March 20, this year in March, to close all the offices all around the world. I'm not sure how many countries, but a lot of different countries. So all the offices are closed since mid-March until June 21. So that's the first thing. And they took this decision already a long time ago, even before Macron and all the politicians decided to do the confinement and all that. So, and I think that's a pretty general thing in many tech companies. So they are very much on the safe side. And so, so it's good. It's also kind of funny because so we have a lot of, for instance, I received some training about how to detect a burnout with Zoom, right? So if you interact only with the camera, it's really hard to know if someone is starting to become completely crazy or not. It's more difficult. So we have a lot of precautions and trainings, and they decided to shut down all the meetings on Fridays, and because they think that we are very stressed. So in my case, it's pretty much the opposite. I mean, this virus thing is a fantastic thing because I didn't have to go to the offices. I didn't have to do all the things I didn't like to do. And so being confined is a great, very lucky, and I hope it will continue forever like this. Probably not. So, but yes, I mean, it's hard. It's hard, but I think it's better than before because you are so free. I think the difficulty is that we don't know how to manage freedom. I mean, we always try to say freedom is important and fight for freedom and fight against people who are against freedom. But in fact, we have no idea what to do with our freedom. I mean, it's very, very clear because people complain that they cannot move. For instance, here, the theaters, you know, the cinema are closed, also the restaurants. So there is a lot of complaints, but in fact, the problem is not, I think it's not so much that, it's just because people don't know what to do. So it's very interesting because it's the first time in the history of the Western world that we are so free. I mean, in the sense that we have all this time, you know, all this time, and many people have. I mean, some people are very, you know, have lots of problems with money and stuff and so forth. But for I guess for most of us, it's not the case. So we have all this time, we have all these resources, and basically we are stuck. I mean, we don't know. We are a bit so anyway. So that's. It does not answer your question, but that's a viewpoint from Paris.
Thank you, Professor Pachet. People are now watching the open conversation, and we have the people from the previous roundtable, Professor Martín Rocamora, and Professor Rodrigo Schramm, and also special guests as Júlio Herlein, Professor Ciro Visconti, Bertsolo, Guilherme Bertsolo, Marco Sampaio, and François Pachet, who is going to present a conference now at 6 p.m. So if we have any questions, I don't know if Hugo can make questions, or Daniel or Almada, or anybody here can continue.
We had a question for beginning this discussion. It's because this quarantine has affected everyone here in classes, as you just said, in classes, in fun time when you're going to spend for watching Netflix or doing whatever you want in your computer, and also in your research. So I'd like to ask you to every one of you, how has the quarantine affected your academic life, like the classes and the way you do your research, and if having the extra time on your home has somehow contributed to advancing your research? I think this is the starting point for this discussion, and who wants to be the first can just start.
Maybe I can answer some, maybe. Hello everyone. I'd like to say that I feel very much like François said before, because I'm really an introverted guy, and I discovered myself to be more introverted than I really discovered me as a really introverted guy. So this lack of social contact, it's not bothering me too much. My wife, for example, she really miss people a lot. She really miss the social contact. So I don't miss so much, and it's a kind of it's just my kind of personality, and I think there is a good side in all this, because we can actually you can go into some subjects in more depth, you know. I built a kind of I built some 40,000 line coding about chords in like 1 month some time ago, and then but I had some experience with my students also, and one of the things that I noticed is that you here in our university we didn't we let the students free from being present at the classes. You know, people, the students can hear or see the lessons, the recorded lessons, in any time that they want to. So at first, I was feeling a little strange, because sometimes people show up in the classes and sometimes no. So after some time, I really started to not feel so so sad if the students didn't show up, you know. And then I just relaxed and I did a lot of videos and stuff like that, and was a period of learning a lot of things, and you know. But this I just wanted to say that it's not only the bad side. We have some good stuff going on also. Just.
May I say something?
Oh, go ahead. Go ahead.
Okay. Hello, everyone. Thank you for inviting me for being here with you. And I'm Guilherme. I'm a professor at the Federal University of Bahia. And concerning this question, right now in there we have a special semester. So it's an experimental online semester. I think every university has this changing for virtual and online ambience. So right now, the challenge is, you know, to change everything for this different ambience that we are not in use to. And from the point of view of teaching, this is a really challenge, especially for, you know, especially for practice courses like composition, or especially I'm teaching right now electroacoustic composition course. It's a real challenge, because how to fix problems, sometimes you have, let me see that, and then you go to a student's computer and then fix everything, and right now it's impossible. I have to, you know, to chat, and then now share your screen with me, let's see the code, what's going on. So it's very hard to do. And from the point of view of research, I think the challenge is because I believe that our main challenge for research in this relationship between music and math at this moment is interdisciplinary research, you know, join people together, especially interdisciplinary research between cognition, music, and math. For example, experimental research that I was doing right before the pandemic situation. We were doing some experimental research with EEG and this kind of stuff, you know, trying to get data from listeners and especially from performers. So, you know, figuring out what is going on, you know, during listening, during performances, especially, you know, this idea of getting data from, you know, statistical learning, this kind of stuff, and how to, you know, how to do research, experimental research during pandemic situations. It's very hard. We have to, you know, I can't do it at this moment. So it's very, I think this is the challenge for this moment, how to do interdisciplinary research, especially this kind of experimental research, because I can do online with my EEG scanner and this kind of stuff. So it's very hard to me at this moment, because I believe in this kind of interdisciplinary research, and, you know, join people together to, you know, to figure out how to research things like we always do. Marcos is here. We did an interdisciplinary research with 9 students and 3 professors, and doing lots of things together. So we were, you know, weekly, you know, doing meetings weekly to discuss things, and it is not possible anymore. So especially when you collaborate with performers and listeners to make experimental research, I think it's almost impossible to do right now, and so it's very hard for me at this moment. So this is my situation at this moment.
Who wanna talk next?
When Julio was talking about being an introvert, and I remember a point that I always recognized myself as a guy that has that dealt good with technology during my time, and I noticed that for me is being very difficult to deal with technology. Everything is done in the front of the screen, and this is very, very, very hard for me. So I don't know if this happens with you.
May I ask a question? Hello?
Go ahead, Amanda.
Okay. I'm curious. I would like to know about you, our guests. How are you dealing with your, specifically with your musical practice, be it composition or performance, or performance?
Yeah, this is. Thank you, Professor Carl. May I answer this question? So yesterday there was a piece that Pedro Bittencourt premiered at the concert yesterday night. So it was very interesting the way we did it, because it was planned for a real-time electronics. So it's it's difficult to get recording and then process everything, and so it's most of the processes are random. It depends on performance, it depends on the interaction between me and Pedro. And then it was interesting because we were we accelerate the processes through this idea of telematic performances. And yesterday some people just said, oh, that was nice how you was looking at the camera to watch Pedro playing. And it was necessary for me because I needed to know what Pedro was playing. And then I was joking with people during chat saying that this is a virtual chamber music, because you have to adapt yourself. And we recorded that through Sonobus, and then I got sign-on from Pedro, and then process that, and then sent to Pedro. And then after that we recorded everything and changed, and I got the recorded from Pedro, and then I just mixed things a little bit, but we made it live. And it's a challenge actually, but I think it was very interesting for us to develop this. This is a special skill that I was a little in use with that before, because I used to do music for telematic performances 10 years ago in a interdisciplinary collaboration with a professor here in Bahia called Ivani Santana. She's a dancer and choreographer who works with telematic dance and this kind of stuff. But it was a couple of experiences, and then right now it's we had to go further and get ways to perform together. I think it was a very nice experience, and then I was really happy with the results we got from the yesterday night's piece. Thank you, Amada, for your question.
Thank you for your question, your answer. It's very, very nice to hear.
Regarding this subject, I would like to ask maybe Ciro Visconti, because I know you give some guitar classes, and I would like to know how is the guitar classes online, because there's a delay problem, and how you're dealing with this. Can you explain a little bit?
Hello, everyone. And first place, my English sucks. I'm sorry. Guitar classes are well, it's impossible to play with someone online because of the delay. Actually, it's possible, but it's very expensive. So I make videos for my students playing, and ask them to make videos of they playing with me, so we can make some duos, virtual duos. So actually, when I lived in United States, I still teaching there and for my students here in Brazil, and I used to do that. So it's not difficult. It's not hard to me to make this this kind of stuff. I already used to making videos for my friend, for my students, and ask them to make videos to me, or I'll ask just the audio, but it's when you teach instrument, you have to see the moves, you have to see the position of both hands. So I prefer the video.
I would ask to Marcos Sampaio, Professor Sampaio, how are you dealing with classes and teaching and research? You can also add a little bit of your research, explain a little bit of what you are doing right now.
Thanks. Hello, everybody.
Marcos, would you turn your volume a little bit up?
Hello, do you hear me?
Yes.
Okay. Hello, everybody. It's a pleasure to be with you here. Guilherme is my colleague in UFBA. We are in a virtual semester. I'm conducting a research in computational musicology, giving classes and with administrative function in the university. In the first semester, I was all my activities related to the research. It was good because I didn't have to give classes, and I could read a lot about this. My research is about the Haydn string quartets. I'm doing an exploratory research, trying to find relations between contours and chords and this kind of stuff in this repertoire. I have some students working with me. They are from music. They have helped me. It's difficult to do the research, not because the activities, the tasks, but the personal involvement is different. The people are not in the same way, working in the same way. My students, I have to give some space to them, but it's a little difficult in this way. In my class, I'm working only with analysis. It's not complicated. The students are doing analysis, and I talk to them in my class. The classes are there are a few people in the classes, and in the administrative position, we are restructuring the composition course at UFBA. It's a huge work. It's very, very difficult. This time, this period, this year, I think we have some good things. I could focus on reading, on doing my research, but there are some bad things too. This contact with people, it's not a good thing. It was bad. And I don't know if I answer your question, Rodrigo.
Yes, thank you, Marcos. If someone wants to add something and also talk about other challenges of your research, not only related to the pandemic, but other types of challenge, financial support or any problems? The other people not from the table, like Rodrigo, Schramm can talk if you want.
Yeah, for sure. I mean, I'm just wondering in the future how will be the financial part of this. I mean, if we start this crisis, maybe next year we will not have funding anymore. I basically don't know. It's just wondering. Yeah, I think it's going to be tough anyways. It's funny because for some companies, industry, even in this pandemic time is quite good for them. Like Amazon's making a lot of money. All these online shoppings are actually doing very well. So I don't know, maybe for some kind of, maybe research in the industry might still very good and even better than before. But for especially in public institutions in Brazil, I mean, public universities, I would say it might be very tough. But again, I'm just wondering, is speculation. I have no idea. Right now, I'm doing research. I'm doing I work in this special project. I cannot complain, but let's see later.
Yeah, I think about three main challenges at this moment. First one is this funding that Rodrigo and Edwino talked about. It's very difficult at this moment in Brazil. I think it's probably next year things are going to get even worse than now. You know, the news about universities' budget are, you know, alarming. So we don't know how we're gonna do things. So this is the first one. And the second one is a personal challenge. I have two children at this moment, and I'd like to say about my huge envy about you guys that talked about we have more time right now with two kids at home. I have much less time than I ever had in my life. So it's a challenge for everyone. So it's changed a lot my everyday life, but it's good, and you know, from a if you talk about a personal life, it's very good. And the third one I was thinking about, I think the challenge right now for my students, at this moment I'm advising two works which has strong connections between music and math, and my research is on music cognition. It's mainly in music cognition, especially embodied music cognition. And I think the challenge for the next research, these two students that one of them is Dennis Carvalho, who presented a paper, I think 2 days ago, maybe. I think it was on Wednesday. And another one is Alisson Silva, that is researching real-time electronics and algorithms for real-time electronics using Markov chains and this kind of stuff. I think the challenge here is how to do interdisciplinary research, especially in connecting cognition and music cognition and math, taking this idea of statistical learning and especially perception, how we perceive music and how we construct meaning in music from the point of view of contemporary music cognition, and how to interact these three fields of research together, as some researchers in Brazil made recently. And in my paper in 2018 for MusMat review, I made a text about the idea of cycle and how it's important for our construction of meaning based on our embodied cognition, and how it works for applications in music theory, and especially for composition. That's my field of I'm a composer, actually. This is my main concern how to compose, how to improve strategies for composition. And there is a paper, Liduino's paper from last year about compositionality, where Liduino discussed idea of forces in compositional systems, taking Paulo Costa Lima's compositionality and take the idea of forces and how to construct, and he constructed two systems, one from scratch, taking nature, forces of nature, like for, you know, for ideas for constructing an excerpt of music. And another system was based on Paulo Costa Lima's Ponteio for piano. And that's why it's interesting, because he, you know, interact the idea of systems, a systemic approach that Liduino has developing since the last decade. And then, you know, discussing that, taking this idea of musical forces to discuss how musical forces and the theory of systems interact to generate strategies for composition, and how it contributes to construction of meaning during composition, and how we listen to music. I think this approach to get this idea of, he cited the Steve Larson's book, that's Musical Forces. I think it's a very interesting book about this idea of a metaphorical listening. So I think this is a challenge for research, actually, how to, you know, to get an interdisciplinary view, and taking these different points of view playing together in a, I think we can go further, you know, especially if we do experimental research with people, listeners, composers, and performers to get data and go further. I think this is a very interesting challenge for next years, I think.
That's interesting, Guilherme. Thank you. I would like to ask for you and for maybe Marcos, Ciro, and I'm not sure if Ciro is also a composer. Julio, I know, composed as well. But have you composed already a piece for this pandemic situation? Because if you type on YouTube, there's a few with the COVID subject, and there's a lot of music coming up from this idea, this pandemic situation. It's a kind of trend for composers right now to use the situation to compose. So I'd like to know if you had some experience like that, or if you're intending to do that in the future or not. What do you think about it, maybe?
I had some feeling in when I had some kind of urge to see and to make music in this period. This urge is more towards expression and less towards theory. You know, in a certain way, I get a little tired of the theory, and you know, there is some stuff that Adam Neely posted, that white supremacy video about about some music that is too Eurocentric music, you know. So I'm discovering the importance of being here in the place where I am, and to really because after this pandemic, we will have to construct a scene of music again, because a lot of pubs. I am a jazz player. I play music. I am a jazz improviser, and I'm a musician that I like to play at bars, at jazz clubs, and pubs like that. So a lot of these spaces are closing. So we will have we will have a great challenge to construct a scene again, spaces to play, and this is really serious, and I think that in this kind of I think that I am moving toward myself now, and less to the theory stuff, but I feel very inspired to see all this Congress and this wake me up again to this theory stuff, and I'm very grateful to you to do this in such a high level, and certainly this Congress will be very inspiring to me to back to think again in a lot of stuff and think again in math and all this. But in the beginning, the first urge was really to make music, and I did some songs, and I started to play acoustic guitar again, and was a more simpler things, you know, and then I'm back again to writing a string quartet and something like this. So I hope I can really figure out.
So Daniel, I think it's a very nice question. Thank you for that. So during this pandemic period, I finished 3 pieces. The first, the piece was Eruption 2 that Pedro premiered yesterday. I started this piece last year, at the end of last year. Actually, we started a collaboration 2 years ago. We always meet each other during these events, and let's compose something together. Let's work together, and then collaborate in some. And then since 2 years, from 2 years to now, we discussed in several moments, and then we started at the end of last year. But I finished during pandemic situation, and then it changes everything, and especially the real-time electronics that we had to rehearse and finish during pandemic situation using different resources that were not in use. And this was very, very interesting for me. And another 2 pieces, one it's called Moving Bodies Movie Camera. That's a video piece, and it's a music and video piece that was it was for a concert in University of California in Riverside. That was a commission, an invitation made by Professor Paulo Chagas to compose a piece for a concert about this movie. It's called Man with a Movie Camera. It's a very famous classic video. It's a very nice movie from 1920s. And then we made during pandemic situation. It was I think it was May or something. The idea was just recording video and sound our everyday life, washing machine and the sounds, our soundscape and the children playing and all this stuff. And then we made this piece. And the third one was a 1-minute piece for Batista Jr. that played this at this project. It's called Pan de Música. That's very interesting project. And that was nice because I was inspired in pandemic situation. And it's very funny and silly, actually. I started the piece with clarinet completely open, with G note, with clarinet really open. And, the piece is getting more and more closed. The clarinet is getting closed and closed during the piece. It was inspiring pandemic situation, actually taking this idea of something that get inside a body and then closed everything. And then that was inspired in pandemic situation. And I discussed this with Batista and how to construct this idea of a pandemic piece. It's called Andaços, which is a word in Portuguese that I never heard. That means a little pandemic. It's Andaços with Cecilia. I don't know how to say that in English. So it's a nice, it's 1-minute piece that Batista didn't play at the concert in Tuesday night, but it was made for him.
Guilherme, I'm just curious about the process of collaboration you did with Pedro. for yesterday's piece. If you could talk a little bit about that. Did you send the files, or there was a real-time sound playing, like using Sagora? I don't know. If you could, maybe composers, they are curious about the process of collaboration.
Yeah. Well, from the point of view of the instrumental writing, we started discussing the instrument. It's sopranino. I've never written a piece for sopranino sax. It's a very interesting instrument, really flexible. It's a sax. It's a sax with a very flexible. How to say that in embocadura? I don't know how to say that in
embouchure.
Embouchure, yeah, it's a very flexible embouchure. So this gestures that wow, it's very easy to do. So we just started with these characteristics of the instrument, and then we discussed the idea of gestures and this kind of stuff, and texting and by phone. And then I made an excerpt and then sent to Pedro. It was last year, and then Pedro recorded that. Oh, this is interesting, and this is interesting. Oh, let's do this thing and this thing, and then we discussed through a WhatsApp calling, and then I wrote the piece a little more, and then sent to Pedro again, and then we finished all the the writing for saxophone, and then from the point of view of the electronics, Pedro just recorded the piece and sent to me, and I was experimenting here with my computer, and then we schedule rehearsal through Sonobus, and then we do try things, and then using sound processing and everything. There is no sound, pre-recorded sound. The piece is all about real-time electronics. I just get the sound of from the saxophone, and then process it in real time. So it was entirely made during our sessions of rehearsal, and using this idea of Sonobus, which is a software that I was not in use with this software. I really recommend. It's an open source software, and it's not necessary to install. You can just compile and and run it locally. It's really safe, and I think it's a very nice tool for doing this kind of stuff, especially if when you depend on getting sign off from performer and then process everything. So it was a challenge for us, but it was very pleasant.
So Sonobus, it synchronizes the real-time performance?
Yeah, they synchronize everything. You set a group, and then you send a link for the performer, and then the system, you can set the buffer, you can set everything, and they calculate the latency and get you very nice. And Sonobus also record the sessions, so you can record Pedro recorded in Rio, and then I recorded here in Rio Grande do Sul, where I'm right now. So I got the recording of our section. I got the recording of the electronics, and Pedro got the recording of saxophone. So we could get everything and put it together in a DAW, and then mix a little bit, and change everything. It's very interesting. I recommend that. It's a very interesting solution for. I think Danilo Rossetti and Silvio Ferraz also used Sonobus.
Sonobus.
Yeah.
It's Sonobus.
Yeah, Sonobus. Yeah, Sonobus. It's interesting. I recommend that.
Would you like to ask, how are you, Ciro? I would like to ask you about your the current state of your research. On graph theory.
I'm doing well, thank you. How are you, Professor? Thank you for being in my PhD. Well, with this this pandemic problem, I have more time because I don't take traffics and at all, and I have a friend who teaches mathematics on Tennessee University. I can't remember the name of the, and he was very interested in my work with the graphs and all, and with this free time we had, we talked about to collaborate in a paper, and we just finished this paper. It's called Alternative Symmetries and Systems. I'm very excited for this ideas because it's a kind of idea that you gave me on my PhD. How do you say banca?
Table. PhD table.
Yes,
Table.
yes. Thank you. Because we are dealing with group theory, and it's very actually all the whole idea came from him, and he came with a lot of mathematical formulas and everything. And he asked why you musicians calculate the intervals like that, like you use. And I explained a little of music theory for him. He played the guitar, actually, so it's easier. And he said, he explained to me that it was a diadraw group. And he said, oh, we can't work with no diadraw groups. So you don't have to be in a geographic system, but you can be in an algebraic system. And we work, and he calculated it has more, almost 10 million different systems. And everyone has the Forte tables, different Forte tables. And so I'm providing the musical examples from this idea.
And do you continue using Villa-Lobos music?
Yeah, no. In this paper, actually, I'm using examples for Webern and for some examples for rock and roll for music. That so I take this the Webern concerts for instruments and change the system. So I use the same 12-tone rows, but change the system, and the music you can have almost 10 million different music with the same idea. So I'm very excited. I probably will finish this week, and we are trying to public in an American journal.
Oh, I look forward to seeing this.
Oh, I think you would be interested.
Thank you very much.
Okay. Thank you.
Maybe Marco Sampaio would like to talk about your composition process during this pandemic.
Daniel, I have not been composing for some time. I was composing a noble solo oboe piece for 2 years, and I never finished it. I never finished it, but I you, how to say, usually I tell my students that any reason is reason to compose. If you have a pandemic, it's a reason to compose. If there is nothing happening, it's a reason to compose. But I'm not the how to say, I'm not following my argument, because I'm not composing, but it's good to be here with you, because in a certain way, it motivates me. This meeting motivate me to compose, to think about something. For instance, every time I read your name or I see you, I think I have to take attention to the texture and the contour, and I have to talk to Daniel about this. So I can't tell you about my composition during pandemic, because there is no composition this time. Yeah.
I know exactly what you mean. I composed only my unique piece I composed this year was that one from Bassoon solo on Wednesday concert. So I'm working more in research than composing, and I need to compose more, to be more a composer than a researcher. So I totally understand.
I have a piece of advice for you. Make composition in your research. So when you're composing, you are researching.
That's a good idea. Yeah.
And that's come to my question perfectly, because I think it was 3 years ago, there was some movement in Europe, especially in Belgium, in your Fields Institute, about the if composition is research and if composition should be in the graduate courses. And here in Brazil, that's a question for everybody. If you think that we could have, as in the USA, DMA in composition, in which the final project is a piece, or do you think the way it is okay? So it's a question that I'm launching to you. Talk about that. Composition is research, or composition is not research, or is it possible to make composition as research, as Guilherme says? That's what I do in my work. I write a paper, and every paper has a piece attached to it that comes from research. So I would like to hear some comments on that.
So Liduino, I think it's a very interesting question. Thank you for that. I think just like Paulo said in Compositionality book, this 2012 book, that composition, it's an interplay. It's more than that. There is an inseparability between theory and practice in composition. When we compose a music, we intertwine theories and practices together, because it's very difficult for me to separate clearly, this is composition, this is my compositional processes, this is my research, because for me everything is really together, because all strategies that I create for composing comes from my music cognition background, and these ideas of research. In Bahia, the graduate program in Bahia was strongly influenced by North American programs. Jamari, for example, studied that there. Paulo Costa Lima studied in United States. Let me see. All the the pioneers of the UFBA's graduate program in music studied in the United States. So our composition program, especially in masters, it's it's much more towards a composition. So you make a dissertation, but it's much more a memorial, something that you discuss, some subject that is important for your work, and then you compose something. But the composition, you know, it's really important for the discussion. I don't remember any dissertation in composition that was made at UFBA that was not composition were not important for the work. I don't remember that. I don't know if Marcus remembers some work that has no work attached, or where the work is not you know, the main topic that was
in Brazil, you say, or
no, in Bahia actually.
in Bahia. Oh,
I'm talking about UFBA's graduate program, especially in master's degree. In our PhD, it's a little depth in you know, in theoretical discussions, but also in our PhD in composition, you have to compose and you have to present your compositions as, you know, a natural part of your work. You know, I don't remember any work that has no composition, you know, that you're not composing during your course. I think so. And any composition is research? I don't think so. I think there is, you know, there is a mode for you know, how composition can be seen as research. But I think the creative processes involves research and involves this intertwinement between theories and practices. And I think it's a natural process, especially in academy, when you compose music and you develop strategies, you know, intertwining theory and practices. I think it's a very, you know, natural thought when you think composition and research playing together to, you know, construct strategies. And that's how it works in Bahia. But I know it's not a Brazilian trend in general. So, but in Bahia, it's very important, this interrelationship between creative processes and theories.
But do you think we deserve to have a DMA in composition, for example?
That's a good question, because we have a professional program there in Bahia. It's called PPG Prom. It's a graduate program, in professional graduate program, and there is no composition in that program. That there is creation, but not composition. The composition area, you know, just I think it's very interesting because this program is very important for the context in Bahia, but in actually what we do in composition is really similar to what they do in this professional program. So what we do in Bahia, it's really similar to a DMA, for example, or MFA in the United States. You know, you write a composition and then you do a theoretical discussion that is intertwined in your work. So I don't think so. I think what we do is, I don't know, it's a very good discussion actually.
Yeah, this is a discussion forever, but that's very difficult.
It's something I would like to add to this is, at the same time, we don't have a PhD in music theory, for example. So you cannot just study just theory. You need to do on composition or on musicology or something like that. So I think we are running late on this topic because we do theory, but we don't call like this. That's terrible between of them.
Daniel, there are many comments in YouTube. I may read them if you want.
Go ahead.
Yeah.
Okay, there's one by George Pereira. He says, "Good afternoon, great table. I listened yesterday to the speech, Guilherme. Great use of the Sonobus for live electronics. I wonder if you want to continue using it with other collaborations."
Yeah, definitely. That's something I'm planning, and I'm planning to keep collaborating with Pedro, because this premiere, we are really happy with the performance and the recording, but we are planning a much better recording with professional cameras and doing a much better processing, and then we're gonna keep collaborating next weeks to record a professional to make a professional recording of this piece. I think it's a very nice tool for this kind of collaboration, and this is my expectation for the future, the next weeks.
Great. We have a question to Ciro from Felipe Martins. He asks, please talk a little bit more about how it was collaborating with a mathematician. And to the other members of the table, he's asking, do you think we should try and make some collaborations like that? So start with Ciro and anybody can add.
Well, it's very hard in the beginning because I have to learn a lot of mathematical stuff because we mix music and mathematics, but we are musicians. We're not mathematicians. So it's a different kind of language, a different kind of thinking, actually, and a lot of symbols, and we are writing in English, so I have to learn the concepts in English too. And at the beginning was very difficult, but in matter of fact, we are friends for this collaborator called Luiz Finotti. He's a Brazilian, but he's living in United States since 98, I think, and we are friends for a very long time. So he got patient with me. So he and after a while, I began to understand his idea, and it becoming easier for me, and I have some ideas too. And actually, I'm thinking about to continue this work with him in a postdoc. With him, I would try to go to the Tennessee University and work with him in a postdoctorate program. But in the beginning, it was very difficult. But I think it's for me. I've learned a lot. I've learned a lot of stuff, and I actually make a lot of new graphs, and with this new concepts I've learned. So it was very good. I really like to do that, and I enjoy to have time to do that. To me have time, and to he has the time too, because he's teaching a lot of classes, and he's also in home, so it got easier, and so I think it's very good to this kind of collaboration.
There is another question by Philippe, but I think this is not addressed to someone in particular. This one I will read. I feel like, but I may be wrong on this one, that the research in music and mathematics in Brazil is currently conducted mainly by musicians and musicologists, and not by mathematicians. As there is a comment, not a question. Someone would like to?
The question is in background. What could we musician?
I have no. It's not here. Sorry. Could you ask?
His question after this comment, his question is, what could we musicians gain or lose by working more closely with professional mathematicians?
I think I was talking about the challenge of research next years, and I think the interdisciplinary research is a very interesting thing to, you know, to do. I think we have to improve this. We are I'm a musician, I'm a composer. That's my main concern. You know, my concern is to develop strategies for composition, and sometimes I have to do some code for that. And for example, at this research we conducted at Genus with Marcos and another professor, a musicology professor, we made a interdisciplinary approach for flute solo pieces from 1910 to 1810, and then got a huge data from that pieces and made files for that and analyze that to get data for composing music, you know, to get Markov chains for adjacent intervals and time and all this stuff. I think it's very interesting, but we got, you know, students from computer sciences and musicology and performance composition, and we have to collaborate with different, you know, with different researchers. I think this is what we have to do next few years, and that I'm used to do this kind of interdisciplinary collaboration, because I think we can move, you know, go further in our research in music. I think there is no lost, that's just gain doing that. I think we improve our area so much doing this.
Guilherme, I already had our math students, no? And the problem was that they didn't know music, or the ability of music was very. I needed much more than they knew. It's a problem. When we talk to some, of course there are some exceptions, but when we talk to a student, a math student, sometimes they know music, they play, they know something about the basic music theory, but we are talking about difficult stuff. So my experience with math students was not very good, because I couldn't talk to them. I think we have to study together, to learn together, with not only with students, but with professors that like music. For instance, at UFBA, we have one in math department. We have another professor. I don't remember the university. He works with music information retrieval, and they are musicians too. They are interested in studying music, but we cannot outsource the math part. We have to work together. So I think the challenge is to keep a group working for a long time to get the results. 5, 6, 10 years after, we will have people well trained in music and math. But if we do research on in short term, it's very difficult to get the results. I'd like also to add a comment about the question, Lidwin's question, PhD and DMA. I have a very personal opinion about the PhD in composition. First of all, we are composers, and composers compose compose. So if I doing a research about composition, I have to compose. It not depends on the program if I have or not to write a composition. For instance, in my PhD, I wouldn't have to compose because I was studying a theory. And if you read the text, you can see, oh, there's no, he didn't have to compose, but I composed some pieces to try to test because we are composers. We have to look at our opportunities, the theory opportunities to compose something. It's my opinion. Okay, in a DMA, maybe the student doesn't write a dissertation, but I think in PhD you have to compose. And one more thing is that research composition. I think when we are composing, we are researching, but as Luiz said, it's very good if we can publish something about the process, about what we are doing in that composition. Doing this, we can help other people to understand some theoretical stuff. Besides Jean-Marie idea, I think was different, not to talk about the composition. But I think if we compose, we can write something about this, about the process to help the others, independent of we are in a PhD or DMA program.
Thank you, Professor Marcos. I have just a comment to do on Felipe's question. I was talking with my ex-advisor because I already finished my PhD, but with Pachet, and we are discussing that we work on music, integral partition theory, and it's something on the math. But we had some ideas for a musical application that probably solves some problem in math that mathematicians doesn't know because they don't think through the music. So maybe we are helping them, but they don't know about us, and they could help us, but we don't know about them. And that's a problem of no talk with musicians and mathematicians. And because of that, all of us here are musicians in the work and in our PhD, in our life, except Hugo, because Hugo is the mathematician of the group. He's from Federal University of Rio de Janeiro, he's a professor on mathematician. He's a mathematician, he's a professor in math. So I'd like to ask Hugo to do his a brief comment about this relationship between music and mathematics from a mathematician point of view.
Daniel, before that, just to add that Hugo is a guitar player.
Oh, yeah, of course.
And he also studies composition. And he also studies composition. So, Hugo, go ahead.
Yeah, he knows music.
To say that I am starting composition is very ambitious, Luiz. I'm having my second course with you. But I played the classical guitar since I was 8. But the university made me stop playing because to learn how to derivate and integrate took me a lot of years. I think that we are dealing with a more subtle subject than the interactions between mathematicians and musicians, and that is interdisciplinary research as an overall. Since my whole academic life, in my second year in the university, I was working with biochemistry, and from the beginning, I was dealing with interdisciplinarity. And the difficulty in talking that Marco Sampaio mentioned is common in, and this is a very sad fact, this is common in almost all interdisciplinary contexts that I have seen. There is a resistance in side A does not want to learn about side B, and side B does not want to learn about side A, and they don't want to talk with each other, but they know tools that can help each other, like Danielle said. There is an interesting book. There are a lot of books that talks about applications of mathematics in physics. And there is a Russian book that talks about applications of physics in mathematics and how do you use physics, classical mechanics, to solve math problems. And this is not very well taught in the university. And even more music and mathematics, that is a much more mystic subject, I think. I think that both sides can win from this collaboration if both sides drop some shields and learn some things about the other side, because you don't know. Up to some months ago, I don't know what is a French sixth chord. This life, it happens, but I am willing to learn. And again, this happens in every interdisciplinary research. I think that is a systematic problem in our academic research. And from the point of view of a mathematician, I have something to say that pure science, pure areas, since I don't consider mathematics as science, pure areas tend to be very purist. And our evaluation committees from the funding agencies tends only to evaluate the papers of the area. So mathematicians are asked to publish papers in math journals, and some specific math journals, some A1 math journals in the CAPES Qualis evaluation. But we have to remember that this evaluation is 4 or 5 years late, because the new Qualis was not published yet. I think that it is not valid. So we have this delay in the evaluation of our journals, and we are asked to publish only in specific journals. And I think that this is very bad to every interdisciplinary research, and especially again in our case of music and mathematics. Happily, I can publish in some papers about music information retrieval, music signal processing that are more correlated, even though they are not well evaluated. They are sometimes even not evaluated by mathematics committee of CAPES. But as Martín said in the last roundtable, I am quite optimistic today also. I think that if we keep collaborating, we can change these things in some years. So, well, from my personal viewpoint, it's only advantage to work with musicians, since I listen music almost every day since I was born. So if I can join my both passions, it is nice. So thanks everyone for the discussion. I think it was very fruitful, and in my opinion, to be aware of the difficulties and the challenges and also the successes of the colleagues, especially during the pandemics, can be very motivating for us to keep our research. In your case, your compositions. Hope that in the future I can say the same, but I can say that my guitar playing. And you also answered a lot of questions that I have made to myself about interactions with students, especially Ciro with his guitar students online. I only had the experience of having presential guitar classes. I never had online classes. So for me, it was very fruitful, this whole conversation. I think that for you also, it was very beneficial. And I think that if we don't have any further comments, we will return at 6 p.m. with the conference of Jean-Pierre Briot and François Pachet on the interplay of composition and artificial intelligence. Okay.
Thank you very much.
Thank you very much, everyone. Great discussion.
Thank you very much, guys. It was a pleasure and an honor to be here. Bye.
Arduino. Oops.
Merde, ça va pas. Mais je veux pas être en plein écran. This one?
Hello, everyone. I'm very honored to introduce the last conference of our Congress that will be presented by Drs. François Pachet and Jean-Pierre Briot. François Pachet is director of the Spotify Creator Technology Research Lab, where he designs the next generation of AI-based tools for musicians. François Pachet got his PhD in habilitation from Université Pierre et Marie Curie, UPMC, after an engineer's degree from École des Ponts et Chaussées. He has been assistant professor in artificial intelligence at UPMC until 1997, when he joined Sony Computer Science Laboratory Paris to conduct research on interactive music listening, composition, and performance. François Pachet has published intensively in artificial intelligence and computer music. He was elected EURAI Fellow in 2014 and Doctor Honoris Causa of the University of Pernambuco, Brazil in 2017. Jean-Pierre Briot is Director of Research of the CNRS and Laboratoire d'Informatique de Paris 6, LIPC 6, at the University of Sorbonne. He is currently in Brazil as a visiting researcher in the UNI-Rio graduate program in informatics. Briot is also a permanent visiting professor in the graduate program in informatics in the Pontifical Catholic University of Rio de Janeiro, PUC-Rio. The title of the lecture is Some Reflections about AI-Assisted Music Composition. Please join me and welcome Drs. Pachet and Briot. Thank you for coming.
Thank you, Carlos, and thank you, Lidwin, and all colleagues for inviting us for this conference and session. So I propose that to start in a way to introduce even further the François's work, to ask him about his recent work and also lesson learned, because that's what, of course, is of more interest of us, because François has been working for a long time in about applied math, computer science, and music domains. So, François, what could you tell us from your experience as a starter?
Yeah, thank you very much for inviting me and Pierre to have I think a kind of informal talk about let's say the situation. As well, in English, a situation is a problem, but the situation is indeed in using AI for music. And the first thing I want to say, yes, is that the situation has changed dramatically over the last years. As we all know, when I started to work on this, and also Jean-Pierre did his PhD in some sense also in music and computer science, the community of people interested in these two things were quite small. And now, for many reasons, this research community has really exploded. There are people doing research in music and AI almost everywhere in the universities, but also in private, companies, and so so it's really, I think, interesting to reflect a little bit and ask like very basic questions of the sort like, what the hell are we trying to do, for instance, which are not necessarily very easy to answer. And so the first thing we wanted, so the way we wanted with Jean-Pierre to talk is a kind of dialogue, right? But maybe the first thing we can say, so here I'm trying to share my screen, so that's the first attempt. Let me try just to show, so I'm not, yes, this thing. So sorry if it's not very nice, but so it's just to say that with Jean-Pierre, it's actually mostly Jean-Pierre's work, actually. We have been reflecting on what is the state of the art in AI, or deep learning rather, and music generation. So there is this book that was out this year, right? And which tries to present a state of the art of the technologies and also the problem. But so maybe Jean-Pierre wants to say something about that. But the first thing I'd like to say that when you write a book or when you write even a paper, you pretend that you are solving a well-defined problem, you know. Otherwise, it's really hard to get this thing accepted. And also, it's the way that science works. So there were a conversation today, earlier on this afternoon, by someone, you know, asking whether music composition, should be, you know, considered as a research subject or even taught at some computer science departments and so forth. And I was thinking always about the sentence I heard in Sapienza, the department of physics, you know. So these guys are really the scientific people, and they say science is only about what we can measure. So if we cannot measure something, it's not science, right? And of course, so I'm just saying this because in this book, and in actually most of the research which is published, we measure a lot of stuff. We measure the loss of a model. We measure various kinds of measures, and there are many. But it's not always clear if these measures actually have any kind of relation with the music problems that we're trying to address, right? So I'm here. I realize now that I'm doing a very bad publicity for this book, but I should not. So maybe Pierre, do you want to say something against this? To say no, but maybe describe a little bit the content of this book, just to show that there is a really very large span of problems and also techniques. It's incredible. Every day there is something new, right?
Right. So actually, as the title of the book says, it's about techniques. So it's more than so it's the motivation for the book was to try to understand what's going on about all this big wave of the recent artificial neural network techniques named deep learning, and the new topic of content generation, artistic content generation. Because just trying to summarize in a few words, of course, everybody's, I guess, is aware now of the use of these actually old techniques coming from statistics and linear and logistic regression, actually, but at a very large scale, used, for instance, for face recognition, for translation. If you use a Google Translate, for instance, that's what's being this is the basis of the technique. Also, speech recognition in your assistants, Siri on Apple, Alexia from Amazon, etc. And but a new domain actually is generation. For instance, keeping up, talking about the intelligent assistants, Alexia, Siri, etc. They also generate speech, and this is also based on the same kind of deep learning techniques. So there's a lot of new kind of new domain of exactly content generation and music. Of course, that's what we are interested about in this conference. Also, images, art, etc. And so we try to understand. Just to summarize the idea. The idea is that this machine learning, statistical machine learning techniques are actually able from a large corpus of examples of some pieces of music to learn some style. It could be the melodic style, the harmonic style, rhythmic style, depending on the corpus that you use to train the system. And the idea from this style which has been learned, you switch to some kind of generation mode to generate new content, and with some degree of control, which is interesting, to make music a little more original and not just a copy of the distribution of the style, actually, which has literally which has been learned. So the book, because it's a very hot issue, and as François said, a lot of research around this. We just basically try to understand what's going on, what are the issues, what are the technical points, and how to match the kind of techniques for learning and for generation, the strategies, what we call the strategies, for the objectives, the musical objectives. So it's so if you're interested to learn more, please have a look to the book. There's also an open version as an archive paper of the book, so it's also freely available. So I will stop there, and moving away from more the technical point of view, going back to the kind of more fundamental scientific point of view, as François said. For instance, he talked about the hypothesis of the cost function. If you know a little bit about neural networks, what is one fundamental issue is to be able to define a cost function, which will actually define how what you train actually the architecture is supposed to work properly. So if you learn a style, okay, this is an easy question. If you it's being able to reproduce some existing music, but for instance, to generate interesting music, there is no cost function, predefined cost function for that. So there's a more fundamental issue, scientific issue, and that François will talk about in a few minutes. So I give the parole to François again. Thanks.
Yes. So yes, I think that's so. Just let's say because and Jean-Pierre and myself, we actually have a plan. It does not look like this, but we have a plan. So the first thing was to try to set up a little bit the history. So just a few words what we did when I was in Sony, and then after Spotify. I think we did interesting stuff that actually created lots of problems. So in 2016, we released this song, which was called Daddy's Car, which was generated from a set of Beatles songs, actually 40 of them, scores, right? So in the form of lead sheets, right? Not audio. And then we composed a new song that was called Daddy's Car, and we released it on YouTube in September 2016. And it created a lot of let's say reflections about, hey guys, what is going on? What is the status of this song? Is it new? Is it plagiaristic? Is it like also some questions which have been raised also today about the copyright? Who owns this? What is the status in terms of legal affairs and so forth, and also it showed, but for us the first thing that it showed that it was actually possible to generate a song, and the song, as you know, is a monophonic melodic line plus some harmonies behind, which is usually very structured and very, like quantized and stuff like this. And so we showed that it was actually possible to generate a song, which I think was pretty good, in fact. So that was the first thing we did in 2016. And then, if we had time, I could show exactly what the AI contribution is in this song. There is clearly, for instance, a passage in the middle of the song, which is actually very similar to the introduction of the song Michel by the Beatles. The harmony is pretty much the same. It has been transposed and a little bit transformed, but still it's very clear that what the AI is doing is, first of all, like it's trying to detect some recurring patterns in the songs of the Beatles, and it's trying to re-instantiate them in a new context. So it is indeed doing something new, but it is also pretty much staying within the style that we have defined before, that we have given to the system. And so that was the first thing. And then in 2018, we released an album called Hello World, which is available this time on all platforms. I want to insist on that because it's actually very important, even from a scientific viewpoint. So the song Dadiska was not released commercially, was just put there as a video. But the Hello World was actually a real music project that we did that we actually produced and released on all platforms, and which had some success. And there are, I think, very interesting songs in there. Actually, there is one song called Sensitive, which is a joke. I mean, not a joke, but a kind of play on word, because it's based on the bossa novas that we love from Jobim, and such as, for instance, insensates, which means insensitive. And so we wanted to create a new song with the same rich harmonies of Jobim and the same kind of chromatic melodic lines. And we called it Sensitive. And if you listen to it, the orchestration is not bossa nova, actually. It's more like a very slow ballad. But just to point you, if you are interested, and you can listen to this on all the platforms. So these are the two things we did. And we did another one, which is Hello World Remixed, where we asked a number of remixers to take some of the songs and do remix of these things. And so we had pretty good, pretty interesting press release. And why am I talking about press release here? Because this is supposed to be a scientific conference. We should not care at all about money, press, media, and stuff. Well, I am doing this because, in fact, the question is, how do we evaluate this thing? How do we say that this is a good album or a good song? You know, it's really hard. And so the first thing that you can do is to look at the popularity, like the number of streams, how many people, how many times the song was played, or things like this. And I will come back on this because it's a very interesting subject, and I will show why it's not a good measure for defining, for instance, for training a model. But the other thing is the press. The press is like human feedback from specialists. And we finally had press people say, hey, that's really cool. It's hauntingly catchy, for instance. You know, so the music is considered as, let's say, interesting, at least for some people. Right. So if I can now focus a little bit on the question that we had at the beginning, you know, what is it that we're trying to do? What kind of problem are we trying to solve? So obviously, so this is not easy because generating music is very easy. You just take a random generator, you draw random stuff, you map this to pitches or whatever you want. You create some noise and you can call it music, and that's it, right? And so obviously what we want is not that. What we want is to generate music that will be interesting for some people, right? And so obviously in that case, the first idea that comes to mind is to look at popularity, which is, you can see popularity as a measure of how people like this song. Either the number of CDs that they buy if you are old, or the number of streams, or whatever, that kind of stuff. And so here, and you could say, hey, it's really easy to solve this kind of problem. You take popularity of songs, you take features of songs. It can be audio features, it can be you know, symbolic features, harmony, rhythm, whatever you want. Now you have lots of models. So, and you could say, hey, we're going to try to build a model that generates songs which are likely to be very popular. In other words, generate hits, right? All right. So I want to take a few seconds, let's say 2 minutes, if you're okay, to explain why this is not a good idea and why actually is not possible. And it's not an idea that comes from myself. So it's a paper, I'm always doing publicity for the same paper, which was published in 2006 in Science by Salganik and Watts and a whole team of people interested in complex networks. And this paper is really not very fun to read, but it says something which is absolutely incredible. So they made an experiment to show basically that the popularity measures are, let's say, chaotic in some sense. And I want to say more precisely what this paper says, because just to destroy the argument that we could do this for music, let's say. So what they did is they took some number of music titles that no one knew, and then played it to people. But they did two groups. In the first group that they called Without Social Pressure, what they did is that they had a web page and they could click on, and then the titles were shown in kind of random order, and they could click on the title and listen to them, and then at the end, the experimenters would compute how many times a music title has been played, right? And each web page for each user was different, was random. And so when they did that, they observed that some titles were preferred to others. So there was a non-homogeneous distribution of preferences, right? So that means that some people are considered better than others by some people, right? So you can call them hits, all right? And that's pretty normal. And in the other group, they did exactly the same, but they would rank the titles according to the popularity of the title within the group, right? So it's what is called preferential attachment. So that's what you have also in many sites. Like when you look for an object, the more popular objects are ranked first, right? And so what they observed that in that case, then you also have hits, but three things. First of all, the hits are not hits; they are mega hits. That is, the non-homogeneity of preferences is much higher than in the other case, which means that when you are under social pressure, you tend to create super mega hits that you don't have in a world where you don't have pressure, social pressure. And second, and this is the most interesting, so these are just summarized here. If you repeat the experiment 8 times, in the group without social pressure, you get 8 times the same hits, more or less. So it's very robust. But in the group with social pressure, you get 8 times mega hits, which are different each time, right? So what it means, or what it suggests, is that when you are under social pressure, which is our case, because the way we listen to music, we know about music, is heavily constrained by social networks, by the society, by radios, by things that we share, right, in common. We are not on a desert island, each of us. So when you are in that case, then the hits are basically unpredictable. So it really depends on initial conditions. This is what this paper says. And it doesn't say it for music, it says it for any cultural market, actually. So it's a very interesting paper. And I wanted just to take a few minutes to say that because these data that we have on popularity are not replicable. I mean, if we go back in time, we start again, probably we have different hits, right? Then it's not a good idea to use them to train a model, because you basically don't learn anything, right? You will learn something is almost not random, but very chaotic. So it's not a good idea. So that was the first thing I wanted to say about, why don't we train a system to generate a hit in bossa nova or whatever? It's because the notion of hit is heavily constrained by social pressure, right? And we cannot predict that. There is no way we can do this currently. Right. At this point, Jean-Pierre, you were supposed to ask me another question. No?
Yes, there was some strange sound, but
yeah. So what we learned with all these experiments is that, first of all, so we don't try to make hits or to generate hits because we don't think it is useful in a technical terms. But we try to make tools that real musicians want to use to help them, let's say, explore slightly new areas. And I say slightly because, for instance, we made the album with Stromae. Stromae is a very well-known singer in France and in Europe. I don't know if he's known in Brazil too, but and for instance, Stromae makes songs in a specific style. He likes, for instance, a rhythm from Cape Verde, or that kind of thing. So we didn't want to generate a pastiche of Stromae. We wanted to show Stromae, or this artist, that he could put the music that he likes and then generate things that he would not have done without the AI, but still things that he thinks are interesting. So things that stay within the boundaries of the style that he likes, right? So what we want to do is to develop tools that help people explore the fringe, what we can call the fringe of what they already know or what they are used to do, let's say. So that was one of the lesson that we had, or even more than a lesson. It was actually even like a strong hypothesis of the project, that we are not trying to generate hits, but really trying to make tools. And actually nowadays in the scientific communities, there is a kind of dichotomy of people trying to make generators. Actually in the book with Jean-Pierre, we talk a lot about pure generation. But in fact, in practice, at least this is my viewpoint, what is interesting in practice is not pure generation, is tools that help people, musicians, explore different musical areas, right? And then decide by themselves what they like. Just to continue, I'm just checking the time, right? Just continue on the lesson learned, because so it's something that that was not at all, for me, was not at all obvious at the beginning. You know, I come back to this idea of evaluation. How do you say that the song that is being generated is good? So in the scientific community, we just measure things. We measure how far this song is from the training set, for instance, using entropy measures typically. We measure whether it is plagiaristic or not. We measure how new it is. We measure how far it is from the training set and and then how far it is from other training sets. So we measure stuff, right? But in the end, we have no idea whether the song is actually good. And actually, the musicians themselves, they don't know, right? So I discovered something very simple, and I know that my colleagues at the universities will scream, and it's a good thing because I cannot hear them now. But so there are two things. First of all, if you work with a musician who is a professional musician, so this guy has a name, right? He has a name, he has a reputation. And so if you generate a song that is not, that he thinks that is not very good, he will never put his name on this. He will never do that, because it's it's personal reputation which is at stake. And so actually it's very simple to know whether a song, not a song is good, but a song, someone like a musician finds a song good. It's the fact that the guy is going to put his name on this, is going to declare it to the society, the SACEM, for instance, is going to say that it's his own song. He wants his name on this. And this is really a very simple argument, but it's actually the strongest way to decide whether a song is good. So all the songs we have released, of course, were signed by the artist, and they were not obliged to do so, and they take a risk, which is a big risk. A second argument, it's a more commercial argument, is whether you can find a producer to produce the song, and he's going to put money, and he's going to take a risk. And as you know, in music, the risk is very high. So because there is so much music around, and so if you find a second, first you put the name, and then you find money to produce it. It's a sign that at least that the song is liked by at least some people, right? And that's a very, very important thing for us scientists, because in fact it's the most tangible way we have to actually evaluate the quality of a song in the end, right? So we learn a lot of this, a lot of things like this. We also learn things which are not very not well understood, but which are quite interesting. So and this is related to a notion which has been discussed a little bit in the literature. I'm trying to find slides here, but I don't. That's all right. Which is the notion of earworm. So, you know, you talk about a song being catchy. A song being catchy means that the song is catching your attention, and you can remember it, and maybe the song remains in your head. So you have this phenomenon that sometimes some songs you play them once, and then they stick in your head. So this is called like an earworm, like a worm, ver de terre in French, that is in your ear, and then you cannot remove it, right? And this is a phenomenon that is studied in music psychology. But as far as pop music or popular music is concerned, I think it's a very high quality for a song to be an earworm. It means that it has something that stays, right? That people want to keep, even if they don't want the song still stay there. So we made some observation that most of the songs in the that we produce in Hello World are kind of earworms. That is, if you listen to them a couple of times, you really have them in your head. But we have no idea why. And it's probably because, again, the generation that we do is exploring a style that is known by the listener, but it's exploring the fringe, like let's say the frontier or just the border, a little bit away of the style, and not too far. But we don't have any precise measure for that. But I think that's a very interesting also subject for the future, like measuring how far songs are remembered and how sticky they are, right? How long they stick in the heads of people, right? So Jean-Pierre, we
yes.
are
maybe
so this is about I will stop this.
Maybe you can speak about not only the issue of a listener finds well, the reverse way, not a listener finds a song interesting, but he finds a song uninteresting. So actually, he would skip it. So probably I would propose you to talk a little bit about this work of you, because I find it very, very interesting, and it's
yes. Yes, so indeed, yeah, we talk about what the user, the composer thinks, what he feels about the song being created. But of course, and that's one of the advantage of working in the industrial world. We constantly ask ourselves, hey, in the end, what are we going to do with all these algorithms from an industrial viewpoint? And so it's not clear. By the way, I want just to do a remark, is that like deep learning models have been around for now, I don't know, and sometimes maybe we could say 5-6 years, or maybe something like this. But you still don't have tools around that allows you to allow people to actually produce or generate a song, a chord sequence, or a melody, or both, or whatever. So you have like research prototypes, but you don't have tools. And one of the reasons is probably that we're still not very sure about how interesting these things actually are for the users. But indeed, so another question is, what about not the guy who is composing the music with AI, but what about the people who are actually listening to this at the end? And here again, I think we basically don't know anything about how people react, how they listen to music, how they feel, what are the emotions which are raised and all this. We don't know much, but we know now a little bit. I want to talk a little bit about that because that's one of the most interesting things personally we have done in the last years. So you have to come back to the streaming thing, right? So you know that in streaming, people, so I'm going to show a smartphone here. So many people, they listen to music with smartphones, right? When I say many, it's like millions or even more. And because there are so many titles available, a catalog on streaming is like several dozens of millions of titles. It's around, I think it's about 50 million titles that you can have on Apple Music, for instance, and the other ones is the same order of magnitude. So consequently, people, and especially young people, they listen to a song and they skip a lot, right? So if they are bored, if they say, "Oh, I don't really like," they skip very quickly, right? And so what's interesting is that we have been studying what we call the skip profiles, how people skip, because the way people skip gives you an indication about how they actually listen to the music, you know. So what they like and they don't like, you could say that's the number of streams, all right. But the skip is more detailed, is more fine-grained. So there is a guy, Paul Lamer, who did already some studies a few years ago about skipping behavior for songs, and he made studies about songs like in general. So if you take all songs, they have the same skip profile, the same overall shape, which is, I think, I don't see if you see, but there is a slide here with the skips. And you see that most people, they skip right away in a few seconds, you know, after before 5-6 seconds, you have a lot of people who skip, you know. So many people skip right away just at the beginning of the song. And then people skip, like less people skip, and usually at the end, of course, people skip a lot because simply the song is finished, right? And so you have, so Paul Lamer, and this is something that's available on the web, has made very interesting studies about skip profiles per age. For instance, there are bumps like, for instance, male, female, age, people, the profiles are slightly different in average. All right, it's interesting. It tells a lot about how people listen to music. So what we have done recently is a bit different. We have looked at the skip profile of one of individual songs. And so this is a typical skip profile. Again, many people, so x-axis is the time of the song, 0 is the beginning of the song, and at the end, it's the end of the song. It's measured every millisecond. And on the y-axis is the number of people who have stopped listening, who have skipped, right? And you see that at the beginning, many people skip. 25% skip before 5 seconds, typically, right? And then after this, you have something, you have another kind of curve, and then at the end, okay, it goes up again. And so what we have been interested is zooming, so removing the beginning and the end because they're not very interesting, but zooming on what happens during the routine mode of the song, right? And so, so typically in this curve upstairs, you have a typical skip profiles, and you can see that there are bumps. It's not a homogeneous, nice curve. It's something that goes like this with some bumps. And so we have discovered a few things which I think are completely fascinating. First of all, if you take a song and you look at his skip profile, and then you look at his skip profile 1 week later or 1 month later, the skip profiles are essentially the same. So these profiles do not vary in time. They do not vary except at the very beginning, of course. When the song is introduced, it's a bit chaotic, but then it's stabilized. And everyone, and the skip profiles are stable in time. That's very surprising because it's not the same listeners, right? It's other people usually. And the second thing is also stable in space. So if you take the skip profile of one song in Europe, for instance, and the same song in the States, the skip profiles are also the same. So it's crazy, it's incredible actually. Are not exactly the same, but they are statistically significantly the same. There is very little difference, and in particular, all the bumps are the same, are located at the same position and the same amplitude, more or less. So it means that the skip profile is actually a DNA of the song. I mean, each song has a very specific skip profile, which is really stable in space and in time, right? So it's crazy, don't you think? I mean, I don't hear people, but I think it's crazy. When we found this, we thought it was a bug. So we looked for a bug for months, but actually it was not a bug. And the third thing that we show in this paper, which was recently published in PLOS ONE, is that actually you can even predict the skip curve, the skip profile from the audio of the song. So that's even better.
François, sorry, can you just put your slides in a presentation mode in order to have a wider, because this is small.
I'd like to know how to do this.
Yes, it's up on the...
present.
Yes, yes.
Sorry.
Thank you. It's a little bit...
Yes, so yes, first of all, stable in space, stable in time, and predictable from the audio. So at this point, some people should say, hey, but if you can predict the skip profile, you can predict popularity. And the answer is no, no, no. I said before we could not predict popularity. No, because the skip profiles here are normalized between 1 and 0. So we cannot predict the absolute amplitude. We can predict the relative amplitude, right? And in fact, if you look closely, the skip profile is made of bumps, which are actually always correlated to musical events. And so what is a musical event? Well, there are lots of composers here, so they know better than me, but a musical event is when something happens, right? So for instance, the guitar starts to play, the singer starts to sing, or the singer stops singing, or the drum starts a solo. Something happens in the music itself, usually with one or more instrument changing their way. And so you could say at this point something very funny that, hey, because the skip occurs when something happens, then if you make music where nothing happens, you should not have any skips, right? And actually, this is kind of true. I mean, if you have a ambient music where you just have a sound texture like a drone, you know, or something like this going on for 3 minutes, indeed, you will not have all these bumps, but it's quite likely that the popularity will be very low. And in fact, there is even a kind of trade-off you can imagine here between popularity and skip profile, and it's a kind of paradox. The more popular a song is, the more bumpy the skip profile will be. That is, in order to be popular, you have to have a lot of skips, which is a kind of strange, but very interesting, I think. And so this work has been only started, you know, recently, and this kind of data, unfortunately, you know, is really very difficult to make public, as you can imagine. But it's the first time, and I'm very excited about that, because it's the first time that you can look really in a very fine-grained way at how people react to music, right? So here, the fantasy, oh, sorry, yes, the fantasy would be, it would be great. I mean, it's not something we can do today, but it would be great to have a tool where you make music. You can imagine your sequencer, Pro Tools or whatever. You make your multi-track thing, and then you have a system that shows you when people are going to skip. And even the next step is to tell you, hey, your chorus is 15 seconds long. If you make it 10 seconds, people are going to skip much less or much more, or, you know, or whatever. Or if you change the sax solo by a guitar solo, maybe then the skips will be different. You see what I mean? So the idea is to go to tools which integrate some knowledge about how people actually react to songs. And that would be really fantastic, because it would help composers to, let's say, literally to play with the reaction of the audience. You know, today composers have no idea about how people react to their songs. But it's only in music that we can do this, by the way. In music, we have the digitalization from the whole chain, from the production, distribution, and with this also to the listening. So we have the whole chain from the creation to the reception. And we don't have this in other media, like, you know, books or movies or whatever. So yes, skips, very exciting. And they tell you a lot of things that so far we ignore about how people react to music. There are other works, ongoing work, which are not finished yet, but where we try to go a little bit farther. We try to understand what kinds of musical event produce what kind of skip, you know. So is it the drum starting, stopping, the voice, the blah, 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 whatever. So trying to build a taxonomy of musical events, which is not based on organology or what we know a priori about music, but which is just based on how people react to them, right? Of course, this can be considered as heretic by musicologists, but that's a domain where we have real data that we can measure. It's in some sense it's scientific, right? So it's interesting to play with these ideas. So that was just the thing I wanted to say about, you know, how people you know, react to music. Just to say, first thing, that we cannot, and I've written papers on that. I think we cannot at all predict popularity, but we can do other things. We can predict how people react on the fine grain, and that's a very interesting kind of data that I think in the future will be exploited more and more. Right. I'm not sure how I. Yeah, sorry. I will skip myself. I will skip to another subject.
Meta skip, yeah, because the time is, of course, always against us. It's 6:46. So maybe I know you have lots of more interesting stuff to say, but maybe can you try to wrap up what kind of what you see as some future questions and perspectives, and
yes,
to leave
so
some time for questions.
Sure. Yeah, I didn't want to show off too much about what we have done, because we did Benoit Carré, who is a musician, called Skigger, the guy who made Hello World, also released an album last year called American Folk Songs, which I think is very interesting. So it's American folk songs for which we had the a cappella voice, original voice, and then all the orchestration is generated by the AI that we have done in Spotify, and I hope these tools will be available soon. I want to end on also something different, because I want to try to bring in this like some flavors about what's going on in the industry, right? And I want to talk about something that also we discovered by, but let's say, thinking about what is the value for end users, right? In the end, why would a musician use AI other than just having fun? And so we found this thing, which is a kind of paradox. It's an open question for us, and I think it's very interesting. And it's the prime of the sense of appropriation. The prime is that, in fact, the smarter your algorithm, the less the user is going to think that this song is actually his song. And so here you have an effect that has been studied from the 60s in psychology, which is nowadays called the IKEA effect. IKEA, like the Swedish company, furniture company. So the idea, and there were already studies in the 70s where, you know, some people release the instant cake mix, right? So you buy a kind of a packet in which you have some powder, right? And the idea, you take this, you put this in a boiling water or something, or even you put it in the oven, and then that's it. And at the end, you have actually a chocolate cake, and it's fantastic. And this thing did not work very well when they released it. And they finally understood that the problem with the users, they didn't have to do anything. So they didn't think that this cake was their cake. So what they did is that they removed some ingredients from the mix. For instance, they removed an egg, and then they tell you, hey, to make this chocolate cake, you have to take an egg, to break the egg, and to mix the, and you have to work and to do something. And then at the end, this thing worked very, very well, much better. And so that's a typical example of the IKEA effect, in which, you know, people are more engaged when they have actually to do things rather than they don't have to do anything. And in economy, it is also studied, for instance, and it has a lot of interesting effects. For instance, so people tend to attribute much more value to the things that they have done, much more than the actual market would tell. For instance, if you have a house and you build yourself the roof, then when you sell the house, you will think that the price is actually higher than what it actually is on the market, because you did the roof, right? And so this is a subject that is treated very seriously by psychologists and economists of all sorts. Now, come back to AI and creation. It's a paradox, because in fact, again, if we want to make tools that people use, and if we want the music that they do to be felt as my music or their music, then the algorithm should not be too smart. If they just have to click on 2 buttons, basically it devalues the thing, whatever it is that is being generated, right? And so I'm not saying here that we should make algorithms that do not work very well on purpose, and then, you know, ask the users to correct the bugs, although that's one way to go. But I'm trying to say that creation and AI, there is still a long way to go to understand exactly what is the role of AI in there. Because if AI does everything, for instance, so I didn't show the examples, but we do a lot of transfer, style transfer, timbre transfer, harmonic transfer, and so forth. So if you do it by hand, I mean, it's really hard to do, and you can be proud of your thing. But now, if you just click on 1 button, you tend to say, yeah, all right, that's just a harmonic transfer, you know, that's it. So you completely devalue the operation, and in the end, you diminish the sense of appropriation. And so, just to tell you that in our context, which is more an industrial context, sense of appropriation is actually much more important than the intrinsic quality of the generation, whatever it is. It's much more important, because what we want is people to use the system and create songs that they like and that they own, right? So that's another paradox. I mean, there are lots of paradoxes in there, but there's another paradox, just to say and to conclude on that AI and music, no, sorry, this is not a well-defined problem. This is a very paradoxical problem in many ways. Yeah, so I think I should stop there, because we are running out of time.
Well, thanks a lot, François. So, Lidwin, we should stop by 7. Really, is it a strong deadline? I mean, or do we have a little extra time, or what's the?
We have some questions. Almada will make those questions that came from the site and from YouTube. But we have the concept that's not. It's 7:30, so we have still some time to.
Okay, good.
Thank you very much for amazing conference.
So maybe
it was a bit improvised.
Pachet, Dr. Briot. I will
so I can
share my screen where I put the questions for you. Just a moment, please.
Okay, so François could. Otherwise, I could read the question to François. How do you prefer?
On YouTube, you mean? Oh,
yeah.
Yes, I can see them actually.
This is the first question by Moreno Andreata. Thanks for the fascinating talk. about the stability of skip profile in time and space, which is in fact an astonishing discovery. Is it also independent of the age of the population? I was saying that my child who skips all the time by listening as many children, and myself, we happen to have the same skip profile.
Hey, Moreno, how are you doing? I don't know. We didn't. So the paper. So the first study by Paul Lamer did indeed look at age populations, and he found actually something quite interesting, that there is a bump in the skip profile, which is, so when you are like a 35 years old, you have 2 bumps. And when you are younger or older, there is less bumps. But these things are about averages, right? And so here you are, so what you are asking is a bit difficult, because you have to focus on one individual song, and then for that song, look at age population. So no, we did not look at this, but it's interesting. I mean, obviously, not everyone skips the same. We are not saying this. We are saying that the statistics, the overall statistic, like each bump if you take a popular song, each bump is going to be thousands and thousands of people skipping at that time, right? And of course, they are not all the same by definition, because people skip at many different times, but it's the whole statistic of this thing which is the same. So yeah, we didn't do this, and I suspect that your child and yourself probably don't skip at all at the same place.
Okay. Second question is two questions by Julio Erline.
Oh my God.
There's some way to access the Flow Machine's lead sheet database.
So I'm not, sorry, I'm not working at so this is belongs to Sony now, to Sony CSL and Sony. So you have to ask these guys. I suspect they will not. I suspect they would not publish make this public, because the legislation, especially in Europe, I don't know in Brazil, but I know in Europe a little bit, is such that if you want, I mean, if you release this, you break, you violate all the copyright rules. I mean, basically the lead sheets are owned by the publishers, right? So, and this is as you know, very important asset of the publisher. You have seen, for instance, recently Bob Dylan has sold his lead sheets. In some sense, he has sold his publishing right recently to Universal, I think, and that's a big thing. So you cannot release this for free. I mean, so I suspect it's not possible. What I would like to be possible one day is to build databases that you cannot publicly release, but you can release some statistical information about what's going on in the database, because this is in the end what is going to be useful, right?
And second question by Julia Line. Certainly, this is important for the commercial side. The algorithm seems to hide uninteresting music. The skip metering is implemented in Spotify algorithm.
No, so the skip, so the skip is more like a prediction. We have implemented, yes, but just for research purpose. It's not used at all. I mean, again, what I think would be great is to have a system where you make your own music. The system gives you advice or commentaries. Let's say, hey, this part, maybe if you move it a little bit on the before or after, or maybe you change it by a saxophone or this kind of sound, you know, then maybe you have a different reaction. That kind of tool, not a tool that tries to optimize your popularity, because this I have no idea how to do, but just try to play with the reaction, you know, of the audience. Because sometimes what you want is to actually make people wait. For instance, if you listen to the Pink Floyd, so I am old, I listen to the Pink Floyd. I mean, these guys, they make songs and the introduction lasts for 5 minutes. So obviously today that would not work on many playlists, but maybe this is what they want, and this is maybe what you want. So So I don't think we should have tools that tell people what to do, right? But it's interesting to know, hey, how many people I'm going to lose, and maybe play with this on purpose, right? Like in a knowledge, I mean, being aware of what's going on, right? But no, it's not implemented. So not yet.
So Pachet used these questions by Rafael Merlo. Professor Pachet used a lot of percentage in presenting the skip profile. Does it relate to the percentage of total skips, or does it also compares the skipped, not skipped ratio?
So the percentage on the x-axis is obviously the percentage in time, and on the other one, it's the number of skips divided by the total number of skips. So it's a skip ratio, if you want this.
There are some comments.
There is, by the way, the paper is on the web, and all the details are there, and also some data. A lot of data is actually made public as well.
I would like to present some comments from the audience. The skip theory is really interesting and says a lot about the music. Maybe the skips are related to expectation, to repeat some feeling in the song. I think that people use to listen many times to parts of the songs they like. Julia like both comments. Very interesting talk, Rodrigo Schramm, and excellent presentation, by the way. Research about how the music is consumed gives deep insight about its compositional qualities, by Rafael Merlo.
Yeah, I completely agree. It's really interesting, and I hope that in the future more people are going to try to make the link between. So this is the end of the chain, the skip, and trying to link the end of the chain to the beginning, the way people compose. Because in fact, I mean, I have composed music, pop music, and jazz on myself. You always have a kind of listener in you, right, who is listening to what you do, and so you have some idea of how this is going to be perceived, but it's only your idea. And maybe a great composer is someone who has a very good idea of how people are going to react to what he's doing. I don't know, but if we can have a tool that tells you, that's even more, more interesting.
Thank you very much. There are more questions.
Yeah, there's one question by Eduardo Cabral from YouTube. He said, great conference. How do you see the suggestions made by the software for songs that you probably would like?
So what is the question is for recommendation for a music recommendation, you mean?
Yes, I believe so. It's how do you see the suggestions made by the software for songs that you probably would like, would enjoy?
But that's the whole domain of music recommendations. Of course, there is a lot of music recommendation in all the music, streaming platforms, and now they think they work quite well. But it's not a domain where I work. I mean, I myself am not involved in this really. I know that deep learning is used intensively to do this. Now there. For a couple of years now, deep learning has also been used to do deep recommendations, and it works really well. But I don't have a lot of intuitions. I mean, it's a domain I don't know if there is a limit to recommendation, for instance. It seems that people working on recommendation, they always try to improve. But is it possible to improve in the sense that it's possible to make a generic algorithm that's going to tell you something interesting all the times, knowing that what you like depends on the hour of the day, on what you have done just before, on maybe you like something one day and then 2 weeks later you don't like it. So it's really hard to see how an algorithm recommendation could be perfect. And so to me, the question is there a glass ceiling for recommendation? Did we reach it already or not? But I'm not working on this domain directly myself.
Well, I think we can finish the session. It's okay?
Cool. Yeah. Thanks a lot, everyone.
Thanks a lot, François.
We like to thank you very, very much for your splendid talk. Both Dr. Pachet, Dr. Briot, we are very honored for your presence. Thank you very much.
Thanks to all.
Thanks for the invitation. And thanks to François.
Pleasure. And now we are going to the last event of the Congress, the concert of electroacoustic music, electroacoustic and alike. It will take place 7:30 in our YouTube channel. I would like to, in name of my colleagues of MusMat group, to thank all participants, thank all musicians, all audience, and wish a great end of year, and invite you for our next Congress in 2021. Maybe in this same format, online format, or hybrid. This will depend on the development of the conditions. Thank you again, and bye-bye.